Yep.
Seems to be working.
Whoa. I think we're here. Oh, no, it was dead for a second. Ready? Yeah.
Good morning. Howdy. Thank you all for coming to AstriCon 2026 as part of SCaLE, the Southern California Linux Expo 23. Our opening panel, myself, Chris May, I'm the open source solutions advocate at Sangoma, and Mike Berdeen, engineer on the Asterisk project, and Mike White, VP of open source at Sangoma. Let's talk a little bit about our day and the event, the next couple of days, what those are going to look like.
Right.
Everybody can see the slides okay on the screen?
Not too bright. All right, let's go.
Great.
Well, that's
So then, Josh Culp is with us virtually. You can feel free to ask a question if it's a specific one to Josh. We're going to loop him in when we have some Q&A at the end of this opening panel, as well as some other presentations that we have later on. So this is our first time here at SCaLE. So thank you to all the new attendees to AstriCon. We've been in Florida for a few years now. Before that, we were Georgia, Las Vegas, Arizona, a lot of places. Sounds like we may have been here about 20 years ago, so welcome back to those who, that's the last time they attended AstriCon. This is my fifth AstriCon now, and I think maybe Mike might have a few more AstriCons under his belt than me.
I think I have the same.
We're at 5, and I know Mike White has a few extras, so.
Yeah, I think I'm around 13 at this point. Anyone else been to AstriCon before? Maybe a quick show of hands to see who's been here. Welcome. Thank you for coming back.
Cool.
Looking forward.
Cool.
Very cool.
Yeah.
All right.
So, and thanks again all the speakers who did come and as well. So thank you to.
Thank you. Yeah. Thank you to everybody.
So there's a pretty nice lineup of talks. We're definitely going to be talking a lot about AI, voice AI in particular, as it relates to Asterisk and all the cool new things and projects that people have been building with Asterisk integrated at the core for a lot of speech to text, text to speech. So we have also a few FreePBX talks. FreePBX, of course, is the most widely deployed open source GUI for Asterisk, the telephony toolkit. We have had a number of recent performance, I'd say, leaps in Asterisk over the past few years, or past year in particular.
Yep.
We can talk about those as well. Josh is going to be giving a talk on that. And we have, of course, a number of great stories about people who have been using Asterisk in a variety of ways, and some other projects that maybe are more tangentially related to Asterisk as part of another solution. Just a bit of housekeeping details. This is being recorded as well as streamed live on YouTube through the SCaLE YouTube channel. So if you do click over to the live stream, you should be able to see each of the rooms. In particular, our room at 9, I think we're the first ones to get started. So hopefully everyone on the internet can throw a few questions in as well. I know that the Asterisk IRC channel has some discussion happening in regards to our live stream feed, so we're going to try to field a few questions maybe from the internet at large if we can. This is important, though, that we are streaming it live, so if you are speaking, asking a question, very important that you speak into the microphone or else it won't get picked up on the recording. We do have some cordless handheld mics that we're going to walk around with when we do have Q&A, so we can come right to you and you can speak into that. And then we'll try to repeat the question as well. Whoever is speaking, as a reminder to our speakers, just to summarize quickly the question as it was asked so that we can make sure that it gets into the final recorded product that is put out. So again, live stream on YouTube, but then cut into individual sections later on when the clips are isolated into individual portions. So we do have breaks scheduled. Of course, there's a bunch of snacks in the back, so feel free to take advantage of those 15-minute breaks. Don't have to be in your chair the entire time. We do have some tables up front for those of you who do need to open your laptop and not place it on your lap the whole time. Feel free to use those. Power is in every row, so you should be able to plug in and charge. The local Wi-Fi, you should have access and information on your instructions. We're in a bit of a dead zone when it comes to cell signals, so be alert of that, but the Wi-Fi is pretty solid. They dropped a lot of APs in the area. Lunch, we have a lunch break for an hour at noon. The restrooms are out if you make a left out the exit and then immediate left, just right down the hall. There's also water in the back and there's water right outside. If you did get a T-shirt, please, if you signed up ahead of AstriCon, please grab your T-shirt from the booth out front and get your badge scanned. Those who did pay the extra attendance fee for AstriCon, you're definitely getting a shirt. Everyone else, please try to wait until our booth on Saturday. We will have a Sangoma booth over in the exhibit hall, so you can pick up your shirt there if you didn't pre-register for AstriCon. We're trying to reserve those to paid attendees. But we do have a few other pieces of swag as well. If you're a speaker, please make sure you grab a mug and talk to our desk about that. Like I said, there'll be a few other points to wear your T-shirt tomorrow for the group picture at the end of the day. So, and we're going to try to wrap up right around 2 o'clock, which is when the exhibit hall opens. So if you are heading back later tomorrow, you might have a few minutes to visit some of the other sponsor booths over in the exhibit hall in the other building. So, some housekeeping.
All right, so we'll start by some announcements for the Asterisk project itself. Version 23 released on October 15th, which is a standard release. We also saw the end of Asterisk 18 getting its updates, which was a very good release, very widely adopted. Was a good standard for a while. We've made a lot of changes for ARI, which we'll talk about. I have a presentation on that. There's a couple other presentations on that, mostly dealing with WebSockets and some other changes. There's also been a big push, as Chris alluded to this year, about performance, right? We're kind of pushing Asterisk as being more of an application platform. So that means ARI, that means performance, that means being able to handle loads beyond just a typical PBX, and of course more. And we'll have more information as we go through. There'll be a full project update given by Josh at the end that we hope you all hang around for.
FreePBX news. Currently 2 supported versions. 15 went EOL in October, so that means we're on version 16 and 17. This is a big deal for us. We're supporting 2 OSs underneath, SNG 7 for our version 16 of FreePBX, and version 17 moved on to Debian 12. We do have a few different ISOs that are coming out. We have reproducible build steps to make your own ISO from some Debian input ISOs, so that's been a focus. You ask where an ISO is, and the tools are in your hands to make your own, so that's exciting. We have a version 18 milestone in GitHub. You can see a few of the tasks and issues that have been assigned over there for our planning with Debian 13, which was released. Debian 13 was released last summer, and we are starting the process of moving on to Debian 13 with FreePBX 18, and the planning for that later this month into the beginning of next month. So that is going to be covered in our big talk tomorrow, as well as sort of like a summary of Asterisk. There'll also be a summary of what's new in FreePBX, including a lot of security advisories, including 4 last night.
So that brings us to how is Asterisk doing? It's doing great. We have active participation across the forums, plenty of contributions. We're getting lots of issues coming in all the time. Our forums have over 8,700 new posts and 630 new participants over the past year, probably even a little bit higher as of now. Over 1.7 million downloads, 1,800 or more commits across all the branches at this point. We try to keep most of them current, but there are a couple that are different between those. And we had 67 individual contributors last year. That includes members of the team internally within Sangoma and also the community members.
FreePBX, how's it doing? Tango, our FreePBX mascot, Tango the Frog, is terrific. We have been tracking some forum site traffic here, our community.freepbx.org site. So we're a discourse-based site where a lot of discussion happens about FreePBX, as well as in our GitHub issues, of course. This is a map sort of our traffic. Kind of almost see a spike from automated crawlers and whatnot over the past year as we occasionally are feeding an LLM with 20 plus years of content from previous mailing lists and other forums aggregated in this modern research. So it's a really great tool for training LLMs. Still a lot of great Q&A, regular posts. I just thought this graph was interesting to show that we are still increasing traffic, and it's a lot of high quality stuff in regards to the forums. So hopefully you get a chance. If you don't, we're all of course on the forums. Asterisk also has community forums, so you can look us up and chat with us there. There's a lot of different threads, topics, and things that are actively discussed, and new Q&A as well. So a bit more of that in the talk tomorrow for FreePBX, but we are definitely seeing an increase in traffic. So.
Cool. So what's new in Asterisk? Performance improvements. Again, we mentioned this a couple of times. The big one was switching to task pool and stasis in PJSIP. So it's a new way of handling the different queued and threaded options. We've got ARI outbound WebSockets and HTTP requests over WebSockets. So this means your entire ARI application point can be over WebSocket. You don't have to have multiple different protocols. That includes, of course, the Chan WebSocket channel driver, which was mentioned here is great for AI and actually came about through some of the feedback and things we had over some studies we had done the year prior. And I'll be giving a presentation on this later on how to integrate those three pieces together to build your voice application, or almost sort of an external module for Asterisk at that point. And then Josh will be giving his project update at the end of AstriCon. We'll really be getting into detail on it. And we always encourage you when you're looking at Asterisk, some things that have been around for a while that you haven't considered, in new use cases can be very useful in the future. The obvious example that comes to mind is the external media, which is how we had done some examples for AI-based assistance there before. But using ChanceBuy and external media, you can build something listening in on your calls and responding to your voice, things like that. So definitely look at tools we already have and on top of the new ones we're adding for you.
So I mentioned, we have a lot of great knowledge-based content as well, the Sangoma Wiki. This is an update that we had a lot of different wikis that contain a lot of different information about FreePBX and ways to plug in. And these have been kind of coalesced into a RAG, and that is accessible through the helps.sangoma.com website. So you can, it's really great for basic questions like, how do I connect a SIP trunk to FreePBX? And it will walk through and collect some different documents to show you a few different ways, summarize that into some easy steps. So that kind of search, AI assisted, has been something that we've taken advantage of as a company. So there's a lot of other areas where you can learn more about other Sangoma products through that interface. But we direct a lot of people there now. It's also a place to open internal support tickets and that kind of thing with Sangoma. So that is in combination with better search tools for our forums and whatnot. So we also have a number of AI text-to-speech integrations. So we have drop-downs integrated, for example, in the FreePBX interface, where you can choose a different back-end LLM to type in your text that you want for your prompts and retrieve back the audio that then you can integrate into your IVR without having to leave the FreePBX web interface. And you can choose between a number of different providers based on your tokens. We also have some internal Sangoma tools that are integrated with that. So, of course, those things, unless you're running a local model, would cost tokens or whatnot. But that is now a little bit more fluid experience to really helpful, like to speed up your IVR creation. Sure. Yeah, Mike, you have a thought?
And absolutely, this is found in system recordings in FreePBX. So if you're using FreePBX, like Chris said, there's the ability now to select your LLM, type in your IVR message, add that to the system, and then apply it to whichever IVR you choose. As Chris mentioned also, it's built into our Scribe product. So if you are using that for some of the sentiment analysis, summary, or other pieces like tagging that we're using, you can also use that for sound files in the IVR as well. So pretty neat piece of new tech that we've added in there, and lots of folks have been happy to use it.
Yeah, hopefully everyone appreciates the sparkle stars behind us there. For that's the key, like AI ingredient to have the sparkles. So There's also been a lot of forum updates. We had a pretty big overhaul of that. Talk about a lot more of these FreePBX things in the talk tomorrow. There are a couple of new repos going to talk about as far as moving some of our actions in GitHub into separate repos. We had some integration for tagging issues. We've kind of expanded that, modeled a lot after the Asterisk CI actions. And then that has been particularly for our new WebLate project, which I'll talk about tomorrow as well. And plenty of new modules in FreePBX, of course, open source. We'll talk about some of those and a lot of other commercial developments that people have had in various places. And so there's still a lot happening in FreePBX. We'll talk about more.
Cool. So let's talk about some upcoming stuff for Asterisk. We're going to have even further performance enhancements. Hints in particular Josh is working on at probably right now as he's watching us. Some ARI early bridging improvements, create and dial to combine together to reduce some weird off-nominal situations. There can be times where between those two states where you can run into some odd stuff. A little bit better. All right. An ARI multiple channel variable get and set, so you can do those together in one request instead of having to have multiple requests to get and set the different variables. And then an ARI attachable state, which would just basically attaching an arbitrary set of data to channels and bridges that you can retrieve or set with those events. And think further improvements to building your sort of off Asterisk state machine via ARI.
And can I just add one? That ARI is the Asterisk REST interface.
Yes.
So it's sort of a acronym in an acronym.
Yes,
Yeah.
REST within REST. Yeah, and you'll see. But you'll see a lot more talk and focus on that over the next 2 days. Cool. So we're going to switch over to questions. So give us a second. We're going to head out into the microphones, switch microphones over, and we'll come around for some questions.
This is on here? Do I need to switch this on?
And we switch off.
Bringing Josh in live from Great Northern.
Check, Josh.
Check, check, check. Can you hear me?
We're listening for him.
Josh, can you hear us?
Yes, I can hear you. Hi.
No problem. All right, first question.
Yeah. Let me introduce myself. So I am head of engineering at Parlance Corporation. We're based in Woburn, Massachusetts. What we do is we build healthcare voice AI assistant. And my first time in AstriCon, I wanted to get to AstriCon last year in Florida, but I just wasn't able to. I got sick. So glad to be here. So coming into this conference, one of the biggest questions that I had in my mind is, architecturally, when you look at Asterisk, right, it's a single-threaded application that is really serving all the calls. Or maybe I'm wrong. But I think what I would really like to understand from you is that, is there any plans in the roadmap to really sort of take Asterisk into a multi-threaded system, or come up with ways so that it's able to really deal with a lot more volume of calls? I would love to get your thoughts on that.
Josh, do you want to step in, or?
Oh, I could talk about this for ages. And I will in my performance talk at the end of the day. So please come and view that. Asterisk itself is multi-threaded. It is actually more multi-threaded than it used to be in years past, particularly our SIP stack. Media handling has always been multi-threaded, and the performance improvements that I've been doing over the past while have been able to push the ceiling of how many calls and such you can do in Asterisk even further. So it will continue to be, as was said in the presentation here, we're going to keep pushing it as far as we can. So what I will say is come to my performance talk and you'll get some better insights into things.
We'll be there. Thank you.
Great. Any other questions from the group? Everyone's an expert already. That's good to know. Don't be shy. Here we go. All right.
Hi, I'm Jeff LaCourciere. I'm the CTO of StratusTalk. We're a hosted PBX company. One thing that I've been playing a lot with is ARI. And for the first time in over a decade, I've managed to crash Asterisk multiple times in a day. And I just wonder, is that something that's going to stop happening?
If you file an issue with a backtrace, then there's a better chance of it.
Yeah, that's definitely a priority for us, so those will make it to the top of the queue.
Thank you. My name is Ed Nicholson. I'm with 0x1b, and I have not deployed Asterisk in quite some time. This time I'm looking to deploy it to a Kubernetes cluster. Is that something do you have hints for that?
I can offer, we had a great talk about this last year at AstriCon, and it is up on our YouTube channel. It was an extensive deployment with, gosh, it may have been 100,000 endpoints for a larger telco. So yeah, this is definitely deployed at scale in Kubernetes in a number of areas, and there's some great resources that we have available at our separate Asterisk YouTube channel, not part of the SCaLE channel, but so recorded talk from last year. Yeah.
Once again, don't be shy. If anyone has a quick question or any way we can help you out. Well, that was an easy one for you today, Josh.
I mean,
All right.
I'm not done. I still got mine at the end of the day, so.
Perfect.
This is only half today. It's only half from me
This
today.
is only half from Josh here today. All right. Well, back to you, gentlemen.
Great. Well, I think we're set. Maybe we have one more slide, or I guess it's just a summary of who we are. And thanks, Josh. And what we'll be around. I guess for a couple of days. Like I mentioned, we'll have a Sangoma booth as well in the exhibit hall. So if we don't get a chance to catch up today or tomorrow during AstriCon, you can come and ask us more questions there on Saturday and Sunday. Thank you again. And it's going to take a couple-minute break here before I fire up. We do have a bit of a change in schedule at 9:30, so I need to boot up, and then we'll present on dynamic location routing in regards to emergency calling, so topic I'm particularly interested in. We've had some difficulties with speaking arrangements. I think you'll hear about that at every other track here. So we are doing the best we can, but I will be talking on that topic in just a couple of minutes. So please grab some coffee, snacks in the back, and we'll get started at about 9:30 to 9:35. Thank you.
Excellent. Good work, Chris. Good work, Mike.
Check, check. Okay. Good morning, again. Howdy. Everybody hear me okay? Great, great. Thanks again for coming to AstriCon 2026. My name is Chris May. I'm the Open Source Solutions Advocate at Sangoma. This is my talk about dynamic location routing and other emergency calling ideas for accurate and prompt response. First, just wanted to start with a quick show of hands. Everyone who, has anyone who's ever dialed 911? Like, is that? Okay, good question. Yeah, okay, that's just about everybody, great. Okay, and then if that was the last time that you made a voice telephone call, please raise your hand. Okay, there's no hands up, great. So I heard that there's a lot of anxiety around making voice phone calls, but this is still one of those places where when you need help, it's very good that you can call and get it there quickly. My apologies to the Europeans in the audience. I believe it's 211 and 112. Thank you. So that shows how much you know. And it's something that it's so common. We kind of take it for almost like a default, like an advantage. But we have to be conscious of how we configure our phone systems so that we are in compliance with all the new rules and regulations, and make sure that the fire truck and the ambulance know exactly where to go. So this is a very important part of my talk. Hopefully this motivates you to, at the end, review your dial plan, be comfortable with deploying these kinds of systems. The goal here is that you can say to yourself, of course, there it is. Probably should have turned off the screen lock. All right, so just to get started here, I will advance my slides manually. So first, I'll talk a little bit about myself and then do some legislative review. Of course, this is a very regulated environment, so it's good to know what's happened. There's been some changes in the past 5 to 10 years that you should be aware of if you're deploying systems like this. So it's a little educational opportunity here. I come up with an acronym, maybe PACL would look better as CLAP, but it's for parse, alert, callback, and locate. And you'll see why it's in that order in particular in just a bit, but look at some practical examples of doing this in Asterisk and FreePBX. And some of our new features that we're moving forward with PID flow, which is not a dance move, but it is a new format for transferring location information that is getting more popularity. And look at a couple of examples of how to do it in FreePBX. And if you do have a question, feel free. We can run around with the mic and grab it and interrupt in the middle, but do please ask those into the microphones. So about me, this is a picture inside from last year's AstriCon. So this is still a popular meme. That is me at my desk previously and then kind of looking at it. So everyone's familiar with the exhibit meme. I heard y'all like AstriCon. I've been deploying these systems for about 20 years independently before I joined Sangoma about 1.5 years ago, mostly in small, medium businesses. So I had to deal a lot with these questions about emergency calling and how to configure these systems and especially keep abreast of all the new developments and regulations. So that was important to me. So, and I just put an Italian spin on the end of it because the word Astri means star in Italian. So legislative review. First off, I am not a lawyer. This is not legal advice. I refrained from inappropriate acronyms and just went with IT. So that's I'll feature that on several slides here as a bit of a disclaimer. Again, not a lawyer. You should ask lawyers though for help. I like personally when I deployed systems to start at the front desk. Legal kind of would come second. Sometimes it came first, but often when I'd walk in the building, the first person to answer the phone is there at the front desk, and they are the ones that if you want a satisfied customer and client, start there. Ask them questions, figure out how they do things, and have them help you test and buy into the system. Also, it's great if you have friends who are firefighters, police officers, ambulance drivers. ask them. They have an organization called NENA, the National Emergency Numbering Association. They have meetings and things too that talk about all these 911 developments and improvements. Kind of comes as a shock sometimes, but you just think about situations where you're in a large building and someone dials 911 in a corner with hundreds of people, and the fire truck rolls up to the front door and no one has any idea where the 911 call came from, and that's a problem. So also private security in particular, very interested in these kinds of solutions. Is when you're thinking about like how to fund a project like this that you're interested in, that's their entire business model, is responding quickly to emergencies before the public safety answering point gets a hold of it, right? So that is a group to consider. Of course, the telephone company's been solving this problem for 50 years or more now, so that's a great resource. And then MLTS or PBX operators like yourselves or your future selves. So this is another great place. There's been a lot of laws. Actually, it was interesting, 911 itself started in 1968, but it wasn't a federal thing and mandated until 1999. And even then, it was sort of a larger question that when it made it through Congress, it wasn't unanimous. We'll talk about that in another couple slides, but these are just some key dates to think about. This came to VoIP in 2008. Very difficult to geolocate IP addresses, so how do you get the fire truck in the right place? And then a couple of new laws that came out, like I said, about 5 to 10 years ago that really affect how we program a lot of PBX MLTS systems. That's a suit of Ready Fox. I think when 911 was being rolled out for children, this was something that was used to popularize how to work with it. So, shout out to the furries in the audience, if there's any. I don't see any right now, but maybe later. So the 1999 bill, this really looked at landlines and also with wireless phones, but the tech was kind of early. It's basically the phone book, right? Like, some people have made the joke that the phone company is a massive billing operation that provides telephone connectivity as an ancillary service. So, but they know where they are, they know where to send the bill. So when someone calls 911, they know where to send the fire truck, right? Like this is part of these, so there's some terms like this that have been floated around that you may be familiar with. I'm not going to talk about these in details, but what we don't really consider these as much now in the VoIP world when we talk about this stuff. Like we have, different terminology, but these are kind of some of the basics, and it's still a huge part of the system. And then in 2008, it sort of moved to cover the Wild West of VoIP, and this was an issue where the geography of your IP device, very difficult. Of course, any sysadmin knows this, so how do we map that to physical addresses? You may have seen, in your cell phone provider when you switch to Wi-Fi calling that you have to enter your address information. That's kind of a solution to this problem. Sometimes clients like the Sangoma Talk line, for example, will switch over to your cellular network to make the 911 call. But still a lot of problems, with GPS in large buildings. How do you pinpoint what floor you're on? And this particular law got something called NG 911 moving along, which we're kind of going to, merge and pick up speed and talk about, that at the end. But this is some of the ball got rolling here in this bill. And NENA was a big part of that. This Kerry's law came about. Tragic accident. Again, if you're bored by this, feel free. I find it interesting, but feel free to grab a snack. This was something that a person didn't know that they needed to dial 9 before 911 from the hotel, which personally I think terrible way to configure a phone system. Never do that. That is just not something that even should be in the mindset. And this law addressed that. So it took a few years to get it passed, and now it's mandated. So on new systems, you need to make sure that direct dialing of 911 is allowed. So we'll look at these a little bit more detail. But it also required that you notify people. So someone needs to know that you dialed 911. The example I mentioned in the front of the building, if they don't know when the fire truck shows up who dialed 911, that's another problem that this bill tried to address. And then providing a callback number. So if the call drops, you need to think about what happens from the 911 operator. They try to call you back, and they need to be able to get through. So these are parse, alert, and callback. Talk about those a lot. That's the PAC. And the first part, we'll look at each of these in detail. the parsing, right? So you need to make sure that your phone system, whatever phone system it is, needs to be able to dial 911 exactly like that. That's it. So you can have a 9 as well, but it can't be required. So you have options. You can do 9911, you could do 1911, 91911, whatever you like. Maybe you map 112 over to it if you have a bunch of European users. I mean, it's entirely, possible that you have a dial plan like that. But the key part is that the 911 needs to go out as that from any phone that looks like a phone. So the alert. Now, what does the alert look like? Well, it needs to go somewhere where somebody can do something about it ideally, right? So a lot of times we see this take the form of an email notification to someone who can act on it, which is one way to go about it. If you have an actively monitored security station, maybe it's a screen pop on their Windows PC. If you have a text message option with your provider, you could send out a page to people. And, we're dealing with phone systems, so why not a phone call, right? Like I think, we'll get, thinking and looking at a few more ideas here, but hopefully it starts some, marbles turning around where you can consider like, well, what if, you can get someone else at your building or your school or your hotel involved early on in the call. So, you have a resource like a private security officer that knows, or front desk operator, who knows exactly that layout of the building. The fire truck, they don't know. The ambulance, they don't know necessarily what's going on inside that building, but you have local resources, and maybe they can get on the call and talk to everybody. Like we have conference calls, right? Like, why it boggles me that it's just a one-way trip between the person calling 911 and the PSAP operator when there's all these other people around who could potentially lend assistance in seconds instead of waiting minutes for the truck to arrive. So just some ideas to think about. Again, I am not a lawyer, and this is not legal advice. There's the IT disclaimer in the bottom right corner, so just some ideas. Callback number, that's the CPAC, Parse Alert Callback. This is important because the main problem is that you don't want to broadcast your main company number as the callback number. If that main company number goes to an IVR or an AI or whatnot, it needs to go to a human being. Whatever number that 911 operator sees needs to be able to connect back to someone who can do something about it. So you don't want the 911 operator calling your main number and having to press, enter your extension number 12. I have no idea what extension just called. I just see this phone number showed up. They need more information. So, just imagine the situation where someone's in an office, cubicle in a corner, incapacitated, they choked on something, God forbid, and then they try to talk and they can't, and your main number showed up, and now how do you reach them? How do you even know? So it happens. People that you want to think about, like, it doesn't have to be one single person either. This could be a group of phones. We have ring groups, for example, in FreePBX. So you can call back a bunch of different people, and one of them can answer and say, all right, I didn't dial 911, but I know that like this area is somewhere I got to start looking around. I'm going to get up and check to see what's going on. Like, who called in my local area of the room 911. So that's an idea with how to maybe position your callback numbers. Now, the locate part, this is a couple of different parts here, but the key part is that you need to have something called a dispatchable location relayed to the 911 operator. So this can't be at a multi-building campus, just the street address then there's thousands of rooms to choose from. It needs to be specific where the ambulance can go. What room, what floor, maybe it's a corner of a building, maybe it's a specific building number if it's small within this campus, but you need to be able to locate the caller. That's the key part. So what this looks like in short form, these code words, building, BLDG. This is a common way to, send this data across. We're going to look at how those fit into your SIP invites in just a couple of minutes with the PID flow. So, parse, alert, callback, locate. Now, I want to show a bit why this is such a huge, I talked to somebody yesterday who was just starting MSP, saw FreePBX sign, and said, I need a PBX. And I said, I just put up the roll-up banners, and they asked, have you heard of FreePBX? I said, and they said no. But they know they need one. And like it's a huge opportunity with FreePBX and the tools we've been putting in place to tackle these kinds of issues. In particular, I'm not going to name names, but I just added this slide so we can go through it together of a certain hotel sticker in the front door. I always like to look at these to see what I should do in case of emergency. And a couple things caught my eye. I don't want to break it down too much. But so first, if there's smoke or fire inside your room, you're asked, now mind you, this is by the door. This is taped on the door. And your phone in the hotel is over by the bed, right? And the cord isn't, I know the cord's not long enough. And if you dial 911 and state your location, your name and address, you're on the phone by the bed trying to read off the name and address that's printed on this sign, because who knows what the name and you know the name of the hotel, but do you always know the address? So now you're ripping the phone out of the wall. And then after you're done with the 911 call, you're also supposed to call the hotel operator at 0, which shout out to all the operators. You know, who thought that dialing 0 for the operator was dead? Well, not at a hotel, right? Everybody just picks up dial 0. So the thought is like, what if somehow these things could be combined so that maybe the front desk knew when the 911 call happened, right? So, and then the fourth step, alert others in the area. Well, okay, here's a thought. All of these phones are in this hotel. What if they rang at the same time and played back some sort of automated message that there's a fire? Like, you know, mind blown. So before you get to the fire alarm, right, this is an unmet need, parse alert, callback, locate. There's still a lot to do here. Like I said, these are newer laws, past 5 to 10 years. Existing systems largely weren't affected. This really is focused on newer systems, except probably for the parsing of the 911 part. You really need to, get that done. And then I found interesting a little bit further down. Now, if you are ordered to leave the room and it's hot, you do dial 911, state your location, name and address, but then it asks you to call the hotel operator and state your location. So I was, like, okay, I know that the first part was just call the hotel operator. So my point is that it doesn't seem like there was, the sign was not, I did not help make this sign. I just took the picture. So there's, definitely some room for improvement here. So ideas to think about. QR code there, we have some step-by-step in FreePBX how to do it. A lot of these things, of course, there's a lot of ways to skin this cat, being Asterisk, FreePBX, open source software, but we have some great resources there on the Sangoma knowledge base wiki. So if you take a look at that code and read up, a lot of some of these things are coming actually direct from that page. But now that we move into some of these ideas, so a couple of questions. If you are configuring a phone system like this, think about how you've been laying it out and what you have been doing with your dial plan. Make sure you're not in a spot where 911 got put into some other use, or that you have some other, definitely do not start your extension numbers at 910. Those kinds of ideas. Like I personally like to start around the 700s. It gives me a few options in the front of the menu for things, and then make sure that I don't interfere with 911 at the end if I'm just doing like a standard 100 kind of phone system, small medium business. And then if you still have analog lines, like that's a different story, because those are really kind of fixed. Like that's more that earlier like MSAG stuff, like phone book, right? Those are really tied in. That system's pretty solid from a different perspective. So we're going to be looking at more like SIP in particular. And then you're using hot desking. That's something else to consider. Hot desking is the idea that you can log into a phone wherever you happen to pick up a cubicle, and that's your extension for the day. And then you go home and you come back the next day. You go to a different cubicle. Now that's your extension. So that's some different considerations. But there's allowance for it in the GUI and the wiki. What does parsing look like in your 911? And this is looking at the FreePBX configs in particular. So just some basic steps. You're going to go into your connectivity outbound routes, add an outbound route, set it to emergency, and then choose the appropriate trunk. your telco in your trunk sequence for how these calls are going to go out. This is just a little snippet of the FreePBX GUI. For those who haven't seen it, we'll have a couple of pictures like this. Those dial plans I talked about earlier, we're going to want to make sure that we include fixes for those errors. So just kind of reiterate that parsing is happening with the 9911. Also, you need to make sure 911 goes out. And then a great idea for testing is 933. So this is something that our wholesale carrier services, Sangoma, a number of providers offer this, where you can dial 933 and have it read back to you a verification of your 911 location address information. Not every telco does this, but it's an automated system that will say, 123 Main Street in a very robotic voice. So there's a couple of thoughts on parsing that outbound route. This is sort of what it looks like in the FreePBX GUI. You can see here, 911, the first underneath dial pattern or the match patterns. Don't worry so much about the prepending or the caller ID matching. Those aren't going to be something you want to consider here. Leave those blank. But this is where we remove the prefix. So in pure asterisk dial plan, there's you can do this kind of stuff as well, but the FreePBX GUI makes it a little bit easier to see. So this is going to allow, for example, 1911, 9911, and 91911. And instead, though, it'll strip off those leading digits and send it out as 911. So what does it look like step by step? User dials one of these numbers. It's going to look at their emergency caller ID setting for their extension. So this is all in FreePBX, how the processing kind of happens, just a flow chart of this. If they do have an emergency caller ID, then we're going to set that outgoing caller ID to the extension's emergency caller ID. And that's what's going to get routed to the telco. And if they don't have an emergency caller ID, then we're going to use the outbound route caller ID. So this can get a little confusing if you haven't, but again, test, dial 933, see what goes out and what gets sent. And this is how to do it in FreePBX. Now we have a question about, there's a couple other things to consider if we're talking about forcing a trunk caller ID or overriding extensions. So you still have a few other things that not as common settings, but the two main things to look at are whether or not you have that emergency caller ID, and if you do, then that's what gets used, and if you don't, then the outbound route caller ID, subject to a couple of caveats. So some alert notifications. These are all things configurable in FreePBX. Shameless self-plug for my GitHub, which worked on some public domain, always be conferencing, some of those ideas about conferencing. It's in AEL, the asterisk extension language, so it's not standard conf format. It's a little different to look at, but it talks about some of these ways to solve these problems using conference calls and other ways to notify. And of course, FreePBX offers a number of these tools now integrated as well. In particular, the open source paging module. So that means that you can drop the caller into, and this we're going to focus on this one, into an outbound group where you can broadcast the 911 call to a bunch of phones. So they can actually listen in. If this duplex is set to no, this is straight out of our Sangoma knowledge base wiki here. So they can hear what's happening on the call, which can be very useful in certain situations to immediately let people know not only, like that a 911 call was dialed, but now you're also like playing back the actual content of the 911 call to others who can run over there and do something about it, right? So this is one way that might be appropriate for your environment to configure it. Walks through a couple of steps there. So this is what that looks like, setting up a paging group, calling a 911 notify, including some extensions in there. So going through some of the steps, again, this will all be online later. Under your additional settings in that outbound route, you'd select for notifications that particular paging group. So that's covered on the Sangoma wiki as well. Looking at version 15, I mentioned that's EOL, but this I believe was it was either 14 or 15 was the first version to kind of allow some of this. I think it was 15, but the current version is 17. So, all right. A little bit of planning now on the callback. This is that question of, what happens if the call gets dropped. So the line's cut, person can't talk, what have you. very clearly, I mentioned this before, don't send them to an IVR. Make sure that they're going somewhere where a human being is going to handle that callback. It might not be the case that everyone in your building has a phone number. Well, that's okay. Like, you can still have a ring group and assign some DIDs just for this purpose to be used in this way. So we're going to look at that one a little bit more. A 3-ring group example of what this looks like for a callback. So kind of a Venn diagram to consider. So let's say we have a couple of phones in the lobby, front desk and security, 701, 702. That's their callback number. Now let's say we have floor 1, we have 3 more phones, 3, 4, and 5. Those are in the ring group as well as the front desk and security. And then we're looking at floor 2, which has another 4 extensions. And in their ring group, they're also in the ring group for callbacks with 701 and 702. So you can see that front desk and security are in all 3 ring groups. So you advertise one of these 3 DIDs based on what extension number in the box is calling 911. And when the call drops, that callback number gets called back, all of those phones will ring. So that's, one way to keep a lot of people in the loop. So maybe it's more important that you don't call back everyone on floor 1 and floor 2. You just want to focus on those primary front desk and security and then these other floors. But that might not be granular enough, right? Like floor 2 is maybe a really big space, and what happens, these rooms are far apart, so how do we know, exactly who called? Like we're still relying on this callback number to patch that call through from the PSAP. So just some thoughts on, how we do this locate, showing this previous diagram. So what if you did buy a phone number for every extension for 911? And this is a perfectly reasonable strategy, right? Like, you can buy single mystic trunking service, retail, every single phone gets a phone number, gets a trunk, and you just stuff this into the address line 2, and it says building in there, and problem solved. You can go on, like, your phone bill is going to be a little higher if that makes sense, because maybe you've got a bunch of power users that, this is a reasonable strategy for you. Perfect, it'll work, right? But it can get expensive. If you're talking a school, limited funds, you're looking at perhaps, many, many different buildings. This is kind of some of the discussions I've had with a shout out to some of our carrier services team in Sangoma. This is something that they have had to deal with, and how do we solve this question? So if you need to chat on that at that level, another Mike, not up here today, Mike DeKazi, is great on this. He has a lot of, a lot of my testing that we're going to be looking at was using our own VoIP innovations, our wholesale carrier services stuff from Sangoma to test this and get this stuff working, what I'm going to show now with our PID flow, and what we've been, generally calling dynamic location routing. So there's a few questions and this is why it's important to check with your SIP provider. We do have that option. Not all SIP providers are going to allow PID flow. What you don't want to do is stuff your invite full of PID flow and have your router fragment it because it's too large, and it doesn't. That's the worst case scenario, right? We're sending UDP and it gets split up on an emergency call, or if your carrier looks at it and says that's an invalid, I'm scrubbing every packet down to make sure that it doesn't contain stuff I don't know about because it could be something, and I'm just going to delete it. Worst, So you got to check with that. Make sure your carrier does this, and this is why I mentioned specifically the Sangoma wholesale carriers. This is I got a test account for free. I work at Sangoma, right? So then you want to make sure that you're using a modern version of Asterisk and in particular PJ-SIP and FreePBX. You don't need to have the very latest, but current is good. And then this particular example involves a little bit of Asterisk config file, so appropriate Asterisk conversation. For AstriCon, I did give a talk about it a little bit at a FreePBX World Summit last summer, but there is a module in the works, but a lot of different ideas on how to do that. So this is also something where your extension map, very important to keep track where are your extensions. right? And so link layer discovery protocol has some extensions where you can configure your switches to relay information to the phone so they can send it out in the invite, but like that's not probably there in a lot of places just yet. So we're not going to talk about that today. Now, I mentioned PID flow is not a new type of electronic dance music. It's the presence of information data format location object. It's been in Asterisk for several years. You may hear about it, geolocation, dynamic location routing. So this is just narrowing down our locations in an XML format in the invite and elsewhere. And you can use a few different ways to do this. For example, we're not going to talk about it much, but for wireless, GPS, although, I mean, GPS is only so good, right? Because in a large building, if you think about it, like right now we're in a cellular dead zone, but we've got, we do have Wi-Fi, but we have wired network here. I mean, a phone in a physical building, it's 10 stories tall and underground or something like that, I mean, can be programmed to know exactly where it is and relay that information more accurately like every time. So like, I think picking up a quote unquote landline or physical SIP phone that's tied into location is a far better choice than trying to dial 911 and in a GPS sketchy environment like that. So a lot of different, we're going to talk about the civic address, a lot of different RFCs with different bits of information. I know George, one of the Asterisk engineers, worked a lot on this stuff, and there's definitely a lot of things that are fleshed out and some that aren't in others. This has been a big talk in Europe in particular. They're also moving forward and actually at the carrier level mandating some of these things before like the actual, the rest of the network is ready. So it's a process around the world. It's part of this NG911 stuff, and it's probably going to be rolling out globally. So this is a good idea for our worldwide audience of FreePBX and Asterisk users, right? A lot of good docs on the internal Asterisk documentation site too from that link at the bottom. We're going to look at the civic address in particular. This is what it looks like in the XML format. You note in particular the location portion of it here, so hopefully that makes sense and what each of those stand for. And you want to see, like, in particular this LOC, this location, this is this detailed like room number, suite number, particular corner where the ambulance is going to go. So we're going to focus on that, and with a couple of practical dynamic location routing examples. So there's two different ways to look at this. Your room numbers match your extension numbers. Anybody, show of hands, who sets that up that way? Room numbers match extension numbers? Oh gosh. All right, thanks Mike. Yeah, okay. Yeah, obligatory. All right, well, great job if you do that. If not, then here's an idea for overloading your caller ID name with some variable location details. And so, again, this is, focus on some FreePBX and how to extend your Asterisk configs to do this. A few common steps to either scenario. So you're going to need to log in to your system, set up a couple of files for geolocation over SSH that you're then going to go back into edit with the FreePBX GUI. This geolocation conf file, I'm going to extend this. So in FreePBX, whenever you need to do something special, it's a good idea to put it in a file a configuration file that ends with _custom.conf that gets picked up and loaded in by FreePBX then. Once you have one of these files, you can go into the configuration file and are now back into the FreePBX GUI and go down to that file and edit your extensions _custom.conf. So do a lot of work in there. Now, this is where we get into you'll see the red part here on your carrier. So some of these names you're going to want to change to adapt to what the name of your SIP trunk carrier is. But a couple of options. This is our carrier office in Pittsburgh. So I configured that in. Now, you're not actually editing raw XML. This is Asterisk, so we're not going to ask you to edit raw XML. That's going to happen for you automatically. The packets go out, right? So you're still editing a comp file, so that can be used by some classy Sangoma phones here. And that, you can see the details. Kind of just looks like a mailing address on the bottom, a little different format, how to break up that address. And now this is the old Digium office, which related, if you're interested in FreePBX learning more, we have some training coming up in the spring at this locations where a lot of hardware is manufactured and is, so there's one of our boxes with a 16-port T1 card. just came out a couple of years ago, so not too long. So that's pretty wild. You gotta have a breakout, panel for it, and then it would go in that box. You can kind of see it once it makes its way in. So that's what that address looks like. And then you kind of glue these together with your location and these profiles. And I just called it CO for the carrier office and DO for the Digium office. And a few other, these are like the minimal requirements, for this config. And that wraps up the geolocation custom. Now you're going to go back into another custom file, which is already there. You didn't have to touch this one because this is just part of the FreePBX. And this is a way to extend your PJ-SIP config. So asterisk configuration, very flexible, but you can it's a templated structure, right? So you can add in a few things. So I've already set up in my FreePBX VoIP in, my unique numbers, so your SIP trunks. So I have a couple of SIP trunks, and that config was generated in FreePBX, and I'm just extending it a little bit, right, by gluing in that particular geolocation profile. And how I'm going to connect those to the phones. And I want to say prefer incoming means that the extension 701, I'm going to use what it's configured to do. So there's a couple different options there about how you can handle that. You can override what the phone is sending, right? You can force it in a different way. But here we're gluing it in with the phone's endpoint. Nothing to do on the phone itself, really. This is in the Asterisk configuration, in the FreePBX friendly version of Asterisk configuration. And there's a key part here. If you have any parts missing or you disable a trunk, then you're going to have a bad time. So, careful when you do this. This is the last couple of slides here, about wrap up. This is, again, scenario 1. This is room numbers, match extension numbers, which doesn't seem like anybody's doing. But this is what you look at the key line here, third from the bottom. We talked about that LOC. That's what's going to change that little bit of XML that goes out by gluing it into and adding the word room in there. And that is what then gets relayed on. And when you verify your address with a 933, you'll hear back 123 Main Street, room 103, Pittsburgh, PA. And second example, this is where we're kind of overloading the caller ID name. So what we've done here is in the FreePBX extensions, in the caller ID name, in the GUI, you actually typed in the room information, and that is then, so it could be, maybe it's suite 567, but it's extension 123. So in the caller ID name, you have something else written, and that is what gets sent then as part of this, information. So here, how you configure a caller ID name, if it's not that important, or you can extend it. So, I'm thinking more of like a K-12 like type situation, school, right? Like it doesn't really matter what the name so much is on the extension for a classroom. I just need to know that it's in that caller ID name. I might have a 4-digit extension, but the room number is 123. And that's the key part in the caller ID name that I want to send out, right? Is the room number, because but I'll also include the extension number at the end there, so I'm getting like both parts of that information, and that's what gets sent in the XML, out your trunk. So that is the end of my presentation, right on time. If there's any questions, happy to run around and ask those. But I hope that this gives you enough insight and thoughts to make sure that your dial plan is sending out 911 exactly, no 9 required, and that you have a few other ideas about how to go about this, and know that this is a huge area for innovation and expansion, and help for a lot of people. So thanks again for coming to this talk about dynamic location routing. Thrown in at the last minute, but happy to answer any questions. Okay, seeing none, we will proceed according to our schedule. I believe we have a 15-minute break scheduled before, is that correct, before Alex's talk, right? Okay, all right, so are you ready to start in 15? Okay, great. All right, thank you so much. Again, appreciate it, and we'll see you back here in about 10 10, 15 minutes.
check, 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 check. Does it work? Does it? You do? I don't hear me. Oh, okay.
2, check.
Is it? Is this too quiet? Yeah. Well, this might be a matter of where I put the mic. Check. Check 1, 2. Check 1, 2. Try it. Check 1, 2. Check 1, 2.
Good morning again, everyone. Woo! My name's Chris May, Open Source Solutions Advocate at Sangoma. Besides opening panel and a impromptu presentation, I will be emceeing much of the event, just trying to give a little lead into folks who are here to present all these wonderful things that they're doing with Asterisk and FreePBX. Last talk about 911 and dynamic location routing, looking at some history and legislative review and where we're at with that system. This is another great talk from Alex Belashoff. He is talking about some history of the PSTN, the Public Switch Telephony Network. So if you've ever made a phone call, you've used the PSTN. I guess unless you've purely used Wi-Fi calling to call other users over Wi-Fi, then maybe you've avoided it. But the corner case there. So Alex is a Cameo developer and contributor, speaks at a number of open source conferences for a number of years, has been a valued contributor and member of AstriCon. We're happy that he is back to talk about the PSTN core. Alex.
Hello. Yes, thank you for that intro. So, as I mentioned, I specialize in SIP service delivery platform architecture and call routing for VoIP service providers. So I'm actually on the carrier and PSTN facing side of all this, which makes me a little bit unusual because a lot of times I'm dealing with things that customers do, higher up the application stack where all the value is created, and I feel myself quite distant from all that. I've been doing this for almost 20 years, and I actually got my start in the small ISP world back when that was a thing. And I got interested in voice and telephony at kind of an opportune time in the middle of the 2000s when Asterisk was just breaking through in terms of mind share, and open source VoIP was having its first moment. So, it's funny because I actually got into Asterisk in 2005 or so, and I thought all this SIP stuff was a little hokey and wouldn't really take off apart from the handsets. And I was very interested in TDM and analog line interface hardware for Asterisk, and I thought that, TDM, ISDN, SS7, that was the future, and that was the really serious stuff. And went to work for SCaLE and VoIP companies, a lot of legacy infrastructure for a while to kind of invest in that viewpoint. And of course, by 2008 or 2009, I had to sort of change my tune and reverse course as SIP, as its role expanded inside the carrier world. First inside carrier networks and later between them. So, in this, my purpose in saying all this is that it kind of brings us in a, I guess, characteristically circuitous way to the real point of this talk, which is that, I think a lot of folks who do VoIP, they think of SIP providers as throwing calls over the fence to an obscure and kind of secretive and predominantly SS7-based PSTN in one sense. And, that continues to be true. But just about as soon as SIP hit any kind of critical mass in the early mid-2000s, I remember there were a lot of triumphant proclamations of the IP peering revolution, that the PSTN is dead, long live the PSTN, you don't need it anymore, you can just send all your calls over IP now. And those of you who have been around long enough to remember, how this started out. Remember that
Alex, sorry, quick check. Are you advancing slides right now?
I am not.
Very well. Sorry. My apologies. Oh.
But I could be. So what I was just going to say there is that, you remember enum and e164.org and well-intentioned efforts like that. But it wasn't long before you had people with more kind of filthy lucre in mind who were racing to proclaim that the PSTN was over. And of course, naturally the new IP peering fabric and high definition voice was happening at, their so-called peering clearinghouse or IP tandem or whatever, but it just wasn't taking. I actually, made a lot of fun of them in those years. And, year after year, this was going to be the year of SIP-to-SIP peering in the way it was going to be the year of the Linux desktop or whatnot. And I did desktop Linux for 23 years. I ran 6 distros. I've been doing it since '97, so I earned my right to make that, take that shot, even at SCaLE. The basic problem with all this IP peering stuff was combination of regulatory and commercial and engineering encumbrances, and then just the critical mass and network effect reality that all your Facebook friends aren't going to come with you to your new non-Facebook social network, even though Facebook is so inshittified. But things do change, and when they change, they typically change in kind of discontinuous step functions, and I think in the last 10 years that's really happened in the PSTN. That's what I'm really here to talk about. So I just want to take you back to the moment when the AT&T monopoly was broken up. Before 1982 or so, AT&T was a nationwide near monopoly, and it served 81% of subscribers. The remainder was served by what we affectionately call local yokels, who remained interconnected with AT&T as necessary. And the Reagan administration broke up AT&T into 7 regional Bell operating companies, or BOCs, often called baby bells. And the idea here was that the BOCs would maintain a monopoly on what we call local loop services within their region, but that there would be competition introduced into the long distance portion, which is the long distance calls that flow between these operating regions. So BOCs could not provide inter-LATA services, while inter-exchange carriers could not provide intra-LATA services. And we're going to get to the concept of LATA here in a minute, but the concept of LATA, local access and transport area, raise your hand if you've heard of it. Okay. It emerged out of this breakup to delineate local loop versus long distance services for the purpose of effectuating the divestiture. So a lot of people I used to think that this was a concept AT&T invented, and that's partly true, but it was previously vertically integrated to a degree that didn't require that. Instead, LATAs were something that arose precisely when the government went to AT&T and said, well, please provide a plan to break up yourself. And so the essential effect of this breakup of AT&T, which most telecom people refer to as either divestiture or the MFJ, the modification of final judgment, due to the changes to the plan that had to be made before the final ruling in 1984, was first and foremost the replacement of the national monopoly of AT&T with functionally 7 regional monopolies. And you remember what these are, at least if you're of a certain age. Ameritech, Bell Atlantic, Bell South, NYNEX, Pacific Telesis, Southwestern Bell, US West. The second effect that was more salient to the anti-monopoly mission of the time was to introduce competition into the long-distance market and to prevent elements of the old AT&T, that is, the baby bells, from leveraging their vertical integration in the long-distance market. They were permitted to maintain their monopoly on local services within their region, but that required defining exactly what local means. Just as a side note, some of the reconsolidation that's happened since then is really confusing. So like, for example, I live in the southeast of the US, and Bell South was bought by AT&T in 2006, which I think a lot of people believe was the original AT&T monopoly, reasserting itself and reconstituting itself, but that's not really true. What actually happened is that Southwestern Bell, or SBC Communications, its underlying holding company, bought out the carcass of AT&T in the late 90s, renamed itself to AT&T since it bought its brand and trademarks, of course. And then, psychopathically wore its skin and presented itself out to the world as AT&T, and that's what acquired Bell South. So I'm sure some of you know, having been around telecom for a while, but the arc of the rest of the mergers and reconsolidations since then has led to a blizzard of confusion. Bell Atlantic was merged with NYNEX and GTE and became Verizon. And US West was acquired by Quest. Quest was acquired by CenturyLink. CenturyLink rebranded as Lumen. Lumen later also bought Level 3. And of course, SBC renamed itself to AT&T, bought Bell South and lots of other things, and so on and so forth. So the local access and transport area that came out of divestiture is a geographic or administrative area that defined what it meant to provide local wireline services as opposed to long-distance services, loosely put. And so these are some excerpts of a US-wide LATA map. So for example, in my home state of Georgia, you find there's about 6 LATAs. They do not cleanly observe state boundaries, as you might note, and loosely they can be said to do so. But the idea here was that if you are a Baby Bell and you are a call, or increasingly data circuits and other services are originating in the same LATA as the one to which they are terminating, then you are providing intra-LATA services, and that is within your remit as a Baby Bell. But if those services are originating in one LATA and terminating in another, they become what are called inter-LATA services, and you needed a special type of regulatory classification known as an inter-exchange carrier, or IXC, to provide this. And so, that was, I'm sure you remember your, MCI and Sprint commercials from the 90s and late 80s and stuff like that. You're thinking along the right lines if you're thinking about IXCs that way. So the architecture of the Bell system after divestiture looked kind of like this, and I'm not sure how visible that diagram really is on that screen. Unfortunately, I don't have a reasonable way of making it any bigger, but it was a hierarchical hub and spoke structure, which is broadly true of telephone networks just about everywhere. So there were 2 types of central offices, which is what they're called in America, but they're usually called telephone exchanges everywhere else on the planet. One was called an end office, which had a subscriber-facing switch that served actual people with actual telephone lines at home. So, your copper lines ran into that switch and either got punched down into a main distribution frame or, were demultiplexed off of some sort of TDM aggregate. Not necessarily TDM aggregate. And, when you called your grandma in the same town that you lived in, that just got switched by that switch, into that switch, out of that switch. But if the subscribers were calling not necessarily each other in that same exact rate center, but someone else who lived in the same LATA, then that was going to be served by a different end office switch. And in order for those switches to communicate, they didn't just all have lines to each other in some sort of full mesh. They had two tiers of switching. They had kind of an end office switch, then they had a switch of switches. And that switch of switches was called a tandem. So when one end office switch needed to talk to another end office switch, they would just go through the tandem. However, if the traffic needed to leave the LATA, it would jump on an inter-exchange carrier or IXC link. And one of the ideas of divestiture was to allow competition in this space. You could choose which IXC hauled your traffic to another LATA. And this is a world where there are many different names for the same thing. If you've been around telephony long enough to remember when end offices were called central offices, subscriber switches, class 5 switches, class 5 offices, and so on. Tandems were called toll offices, class 4 switches, class 4 offices, and many other things, some of them savory. So I'm going to stick to end office and subscriber-facing switch here for the end office and tandem for intra-LATA and IXC switching. This tendency to have lots of different names for the same thing extends to other parts of the system as well. But first, the Baby Bells were called Box. Then they came to be known as Regional Bell Operating Companies, or RBOX. I knew plenty of people in my managed modem days who called them Reeboks, like the shoe. And this tendency is pervasive in this world. So this diagram here deliberately shows 2 tandems in one LATA and 1 tandem in another LATA, which illustrates the variation in how tandems were designed. Some LATAs had 1 tandem. The LATA I live in, 438, which covers the midsection of Georgia, has 3 tandems, which of course have big fat interconnections to each other. It's also fairly common for buildings that have a class 4 and a class 5 switch, or that is to say a tandem and an end office, to be in the same building. That seems almost universal in some ways. Around the mid-'80s, point-to-point T1s, frame relay, ATM links, stuff like that came to be more significant as well. And they followed a similar logic in terms of their design through the physical elements of this system, but that would be a whole presentation in itself. So that's how the system worked, and nothing really very substantial changed until the Telecommunications Act of '96, which I'm sure most of us have heard of. That was undertaken in the Clinton years, and it represented a very, very large structural change to the telecommunications architecture of the US. There are absolute volumes and reams that one could say about all the different spheres that its tentacles touched, but for purposes of this discussion, the main thing that it did was it opened up intra-LATA services to competition by requiring the incumbents in that LATA, that is the bells that were already there, to interconnect with a new category of entity called a competitive local exchange carrier, or CLEC. I'm imagining most have heard of the term CLEC here. Yeah, okay. It mandated lots of other things that would go into introducing an element like that into intra-LATA services. Number portability, very, very complicated reciprocal compensation structures within operators pay each other to take their calls onto their network. Various elements of the Bell system that had to be unbundled for resale. That is to say that they were regulatorily obligated to allow competitors to potentially sell parts of their network, both retail services and the physical componentry. Lots of implications for the broadband world as well, which is where I started out. So, in essence, a CLEC was an entirely new kind of company. Obviously, the incumbent carrier, the ILEC, which for most people was the baby bell, had the phone lines and the switches already in the area. So, the idea wasn't really that a CLEC would start building a parallel duplicate of this from day one, running along the same rights of way or whatever. Instead, the idea was that CLECs could offer new kinds of services over diversified network architectures and kind of overlay this. And the main requirement as far as CLECs were concerned was that the incumbent interconnect with them. So, in other words, if you were operating, for example, in the midsection of Georgia where I live in LATA 438 and you wanted to start a CLEC and you went through the process, Bell South had to interconnect with you. Now, the exact terms and conditions were to a very large extent determined by them, but they had to interconnect with you. This was mandatory. So the way this would work in practice is that you would go to the ILEC and you would say, I'm going to simplify here a little bit and say, I'm going to pay half the cost of this fiber to go to this location. In practice, it was usually an end office known as the POI, or point of interconnect, and they have to pay the other half. And as part of this kind of cost-sharing arrangement, you would physically plug into one of their end offices, but your goal wasn't really to talk to an end office switch. Your goal was to talk to a tandem, since the tandem is the heart of the beast, the heart of this whole nexus. So you would physically have trunks that would, or physically have a link that would go to an end office POI, but what you really were after logically was tandem connections. And so you would buy tandem trunks through the incumbent's network, and they would drag your traffic over their network from your POI and drag it back to their tandem for you. You would have to pay them for this privilege, and the anatomy of that cost structure is extremely complex and varied. So CLECs were also LECs, that's the LEC part of CLEC, so they were local exchange carriers, so the scope of their operation was ostensibly LATA by LATA as well, although to a much lesser extent than the baby bells, which were explicitly prohibited from offering inter-exchange services. So that's a lot. So let me offer an amended version of that diagram. CLEC interconnects in the ILEC tandem. So here I've zoomed in on one of the LATAs in my previous diagram. And you can kind of see that there are two new actors here represented by orange links. And you can see that I'm probably spending a lot of time on the physical aspect of how they connected, but really their goal was to go to the two Death Stars in the middle, and those are the tandems. And so you would buy tandem links to connect to the tandems of the ILEC in your LATA. And if you wanted to operate in multiple LATAs, you would do it for every LATA. And this was expensive, difficult, and arduous. So there's a whole nother aside here about that as a matter of historical interest about whether you actually have to connect to one tandem or all the tandems that might be present in your LATA. And if you had to go around if you could connect to one tandem and have the bell drag around the traffic to its other tandems, that was known as multi-tandem access and was allowed in some places and not others. But anyway, most of the time you needed to buy your own tandem trunks from the ILEC. That is to say, reserve a portion of their network capacity to haul your traffic to all their tandems in that LATA. So after TA96, you could argue that the role of the Bell or ILEC tandem as a switch of switches became even more central in some ways, because they weren't just switching the ILEC switches, but they were switching everybody's switches. Burgeoning wireless operators, paging companies, long-distance companies, and now the local CLECs too. So the tandems are where the IXC trunks landed, bringing in calls from other LATAs. There were places where intra-LATA companies outside the Baby Bell's footprint, the local yokos were interconnected with the Baby Bell as well. And of course, that's where the CLECs went as well. More importantly, as CLEC's traffic footprint got bigger and bigger, there were also places where CLECs exchanged traffic with each other. So in all cases, the upstream ILEC tandem was the default gateway to the world, the default route, the switch of switches, the plexus, the nexus, the end-all be-all. And suddenly there was a lot more inter-carrier traffic to move. So what did CLECs actually do? They did a lot of different things. In the 90s, you may remember they sold outsourced managed modem to internet providers. They did some broadband build out in the sense that they built fiber rings, and especially in metro areas got leased fiber, or in some cases trenched fiber, and got various office buildings connected to it, and then could offer services to tenants on the 17th floor off their rings, stuff like that. There was a brief opportunity to resell the ILEC's own retail services, i.e. dial tone, through an arrangement called UniP that was required by TA96, but that didn't last very long. But I think for purposes of this discussion, the element of what CLECs did that we really need to focus on is that they became the back end of the VoIP industry. That is to say, they started to provide wholesale PSTN origination and termination to the VoIP industry. And I'm going to tell you why. One thing to consider is that, just to go back to the LATA idea for a second, one does not simply become a nationwide CLEC. This wasn't LATA by LATA process, and it's very complex. Interconnection agreements are often hundreds of pages and laboriously spell out all kinds of inter-carrier compensation mechanisms and exactly who pays for every inch of what in this equation at the LATA level. Although, from an administrative point of view, it's often simplest to opt into an existing interconnection agreement of someone else already has filed. And that's done all the time. And there's what, like around 200 LATAs nationwide, so one does not simply become a nationwide CLEC. So by volume, most CLECs narrowly specialized to offer stuff in their local areas, which was sometimes called, wholesale origination or termination fairly early on. There were definitely folks who got a particularly cute ICA with their Baby Bell in their particular area and specialized in offering wholesale termination or origination just there. And some of you may be familiar with some of the arbitrage and inter-carrier compensation games that were played in this era. But some companies methodically obtained CLEC status in more and more LATAs, and eventually in just about every LATA, to the point where they could offer inbound and outbound termination just about anywhere in the country. This was, in a way that's often understated and underappreciated, often driven by investments during the managed modem era, when you had to offer dial-up numbers just about everywhere. And you probably know that back in the days of Net Zero and various dial-up providers in the 90s and this explosion of cheap dial-up service, it was often level 3 managed modem that was the underlying facilities provider for that. So the ISP would slap its label on it, but you were dialing into level 3's modems. And this is how they grew a lot of their network. So the appearance of VoIP in the early 2000s provided this type of managed modem-oriented CLEC with a new opportunity. Because if you think about it, dial-up aggregation hardware is just a bunch of DSPs in a box that would typically take a large TDM link. And converting PCM audio from TDM frames to IP packets is also kind of a DSP workload. So there's a lot of fungibility here, to the point where some of the same boxes were often used to do this. So not a lot of people know this, but the reason level 3 had such a comprehensive nationwide origination footprint back in the day, to where if you were doing VoIP in the 2000s and you were thinking about the DID Anywhere company, it was probably level 3, or some reseller of level 3 like Bandwidth. It was because they leveraged their managed modem network into that. It's not an accident that Bandwidth started out as a level 3 reseller before they got their own CLEC, first in the highest volume, most lucrative metro markets, and later in other kinds of markets. So that's not too different to the story of a lot of other nationwide facilities-based wholesale providers that we know that are in our vocabulary now. So for most of the 2000s and 2010s, VoIP providers bought DIDs, PSTN origination, and outbound services, that is PSTN termination, from underlying carriers, which were large CLECs. Some, depending on the scale and size of what was going on, it might be hyper-local, but chances are it was probably regional or national. Or from a reseller who sold the services of underlying carriers. So this led to a lot of specialization where business-to-business interfaces and processes were made to be consumable to this industry of ITSPs, number porting, CNAM, all that kind of stuff. ILECs were not interested and are not interested in selling services to the VoIP industry by and large, and to some extent are regulatorily hampered from doing so as well. So this meant that translating VoIP calls to and from the PSTN was an opportunity left entirely to CLECs. So as I said, in practice, being a VoIP business in this era meant at some level buying the services of an underlying carrier or reselling the services of someone who was selling the services of an underlying carrier. You're a reseller of CLEC footprint unless you happen to be vertically integrated with a CLEC. So underlying carrier meant one of an oligopoly of large CLECs who were set up to provide SIP to PSTN conversion, if you want to think of it that way, in a way that is consumable to over-the-top VoIP service providers. And so, throughout all this, the ILEC tandem remained the big aggregation router where all the traffic met, by and large, not exclusively. You can imagine that it's possible for a CLEC that does SIP termination to get a private SIP interconnect to another major CLEC that also does termination via direct circuit that bypasses the ILEC tandem. And this sometimes happened, especially in dense metro areas. But oftentimes it was just a problem if it wasn't economical. At the end of the day, it just doesn't matter. You weren't passing enough traffic between, level 3 and global crossing to where it made sense in most places to bother to do that. So they just ran it all through the ILEC tandem, more or less. And, that's as mobile operators came to play a bigger and bigger role. They too connected to the ILEC tandems, and so you wanted to call a cell phone? ILEC tandem. Wanted to call an ILEC landline? ILEC tandem. Wanted to make a call from your VoIP handset to a call that would ultimately terminate in the VoIP handset of another VoIP provider that is also using a different underlying carrier for the inbound? ILEC tandem. So at the end of the day, if you needed to complete an intra-LATA call, holla at the ILEC tandem. So technically, CLECs needed an IXC license to move traffic inter-LATA, but it wasn't terribly difficult for them to obtain this status either for the same entity or for different entities that they both owned, which in some cases were connected to ILECs. Still, by and large, the tandem was the meeting point. The ILEC tandem switches were TDM and they spoke SS7. That meant that a large segment of the industry continued to exist as a necessary adaptation layer because VoIP ITSPs lacked both the technical means and the desire to invest heavily in TDM gear for legacy interconnection, and because they didn't have the CLEC status required to interconnect with the ILEC in the first place, and we'll get to where that changed. But you kind of start to see where this picture's going, right? So any future evolution of how calls are sent and received among different providers was really going to be a question of how the world, comes to lesser degrees orbit around the ILEC tandem. So things did quietly shift during the ensuing years. I already mentioned that mobile became more central to the point of now, I'm pretty sure that if there's an age cutoff below which you think of calls as just going to and from cell phones and don't even pause to consider any other kind. But as landlines declined, making and receiving calls from PSTN subscribers increasingly just meant sending them to, T-Mobile, Sprint, and AT&T, or Singular, or whatever they were called at that time, and Verizon. And mobile operators, unlike ILECs, were more willing to do private SIP interconnects with major CLECs. This became increasingly true over time for reasons I'll touch on briefly. A lot of phone lines that people perceive to be landlines because they go to traditional phone systems simply became VoIP quietly under the hood. There's the much vaunted VoIP conversion, but then there's also the kind where you have a, Lucent partner messaging 2 system from the early 90s that works just fine, but now you get your phone lines from your cable company instead, the same people that provide you internet, and you don't even really think about it. They're just phone jacks you plug into on the back of some box, and apart from the fact that they're both down at the same time, there's really no reason to get into it that deeply. So a lot of business lines in North America today, such as they continue to exist, are broken out of the back of an ATA or an IAD type device and are provided by a CLEC or a major cable operator. There is, of course, the whole IPES thing. Anybody here heard of IPES? IPES? There's probably a good reason for that. So throughout the 2010s, the FCC did, via a series of orders, slowly erode this monopoly that CLECs have on owning numbering resources, and in general doing things that make them a first-class citizen in the PSTN. Now, that doesn't mean that today you can start a VoIP company, get an IPES certificate for it, and participate in the PSTN on the same terms as CLECs. We're simply not there. But things are further along in that direction than they were before. And finally, IP tandem operations did become more sophisticated and gain more critical mass, and this was to a very large extent a commercial accomplishment. So obviously the most well-known one is neutral tandem, which then became IntelliQuent and was acquired by Cinch, and I'm not sure what they're called this week. But neutral tandem is increasingly, or I'm going to call it that, which really dates myself, but neutral tandem Cinch is essentially has become more or less the consolidated, agreed upon one-stop shop for exchanging traffic via IP. That's not entirely true, but it's substantially true. So I think there was a watershed moment in the mid-late 2010s where really things did start to change. Because as late as 2015, I was on record saying, the SS7 TDM PSTN will always be here, and to some extent it still is. There's just so many layers in this thicket that are hard to untangle. But I think it is fair to say that we live in a much more end-to-end IP world in 2026 than we did in 2015 or even 2018. And if I were to draw you a picture, give you an architectural diagram of the PSTN, both from a commercial and an engineering perspective 10 years ago, I think it just would look very different than it does now. And I think one of the main reasons for that has just been the move of mobile operators to IMS VoLTE cores that are SIP internally, where it's only a very natural leap for them to interconnect via SIP to other carriers. At the same time, the emergence of a plausible and durable peering fabric in one place, in the form of Cinch and some other folks, has made it far more reasonable to say we're going to bypass the ILEC tandem. Now, the idea that you're just not going to connect to the ILEC tandem at all anymore as a CLEC is not plausible or on the horizon. But in terms of the utilization and the investments you have to make, the bar has become much lower. One of the main reasons that it's become much lower is that you don't actually need an SS7 speaking TDM switch anymore to do that. There are as the traffic volume pumped through the ILEC tandem decreases, there's a bunch more stuff that you can do now to offload some of that cost. I would say they broadly work in two directions. One is that you get your own SIGTRAN box that, there's a couple of different options there. You can get a piece of equipment that takes SIP in one end and spits out SS7 on the other and still get all the A and F links from to the ILEC tandem, or you can more or less outsource this problem entirely to someone who handles all the SS7 interfacing for you and you just send them SIP. And there's kind of an intermediate setting where you can speak SS7 directly, but using a protocol called SIGTRAN, which is essentially SS7 over IP. And someone else converts it to real SS7 for you. So that has become a lot more pervasive. There's an FCC push to phase out certain aspects of the Telecommunications Act of 96, Section 251C2, incumbent-specific TDM interconnection obligations by 2028. And what that really means is it used to be that you as a CLEC have definitive interconnection request rights. You can demand that the ILEC interconnect with you, but to a very large extent, the ILEC gets to set the terms and say, well, this has to be TDM. That's slowly being pushed out. And, you know, probably one of the most significant shifts that has made this more advantageous for CLECs in terms of private IP interconnects is just that the industry consolidation has made it so that you send traffic to a smaller number of places. It's you know, probably 70% your mobile operators and a smattering of other large CLECs that represent a very small oligopoly that basically feeds the whole industry. Yes, and also cable majors, and also you have to figure out how to reach the various non-RBOC yokels and so on. But you can patch this together in a way that's much more feasible than it used to be in terms of network footprint. So what that means is that if you are a CLEC and you want to have a private SIP interconnect to T-Mobile, you can interconnect with them not on a laborious LATA by LATA basis, but just at a few IP pops around the country. And you can pretty much just peer with everybody that way, else through Cinch, and anyone that you still can't reach, I guess you still have to fall back to old reliable ILEC tandem. But there's become a lot more end-to-end IP solutions to that problem, and of course that has lowered the capital barriers to entry. So we're undergoing this metamorphosis right now in a way that if you had asked me 8 to 10 years ago, which to the mind of someone as old as me is not a particularly long time, I would have given you a different answer then about where we're at, about whether the ILEC tandem is still where the buck stops. That is very rapidly not becoming the case. And there's obviously a great deal that one can say on this topic, and I don't want to, bloat the context window with too much information. And just TA96 in particular is a very complex topic and had manifold implications for many, many different parts of telecom. The one other thing I wanted to say about IPES real quick is just that, a relatively small number of VoIP providers have IPES status due to its limitations. IPES did gain considerably more traction in the 2010s, but there are parts of the PSTN where TDM is still mandatory, especially small rural carrier connections that still require TDM under existing ICAs or even state rules. An IPES-only VoIP provider isn't going to build nationwide TDM facilities, so in practice, they're still going to have to ride a TDM interconnected CLEC that already has trunks stitched into every ILEC tandem everywhere for, to reinforce the parts of their network where they can't connect to someone privately. And so when you're doing that analysis, you're thinking, well, maybe I should just send them everything. It's cheap. So also number portability, intra and inter-LATA routing, inter-carrier compensation, new generations of 911 requirements, and of course, as I mentioned already, the limitations on IPES providers as information service providers, ability to demand interconnection from ILECs, all limit the utility of IPES. So I don't know that we today can say that becoming as an ITSP, that if you gain your IPES certificate, then you can play on level footing with TDM interconnected CLECs. But we're going in that direction. So with all that said, thank you very much. I'll be happy to take some questions if you have a couple. Go ahead. Oh, sorry.
Yeah, sure, thanks.
I'm not sure if it's in my purview to point at people or not.
Hi, first off, thank you for the presentation. I wonder if you can touch on stir shaken, traffic pumping. CLECs have done obviously a lot of good for competition. but there's a lot of bad actors out there, and if we are moving away from the PSTN, why is stir shaken such a problem? Why is number spoofing such a problem? And what do you see going forward? And is this a 10-year fix? Is it a never fix? Just like email, we have spam. What do you think?
Well,
So just to restate the question, it's about stir shaken and traffic pumping and number spoofing.
I can say relatively little about stir shaken implementation bumps, and the main reason for that is just that it's such a complex situation by situation topic as to why it doesn't deliver what it promised. Certainly one reason is that there's pieces of call routing that require TDM in the loop, and while there are various mechanisms proposed to propagate stir shaken through that piece, it's not there. The traffic pumping thing is interesting. So I don't know how many of you are familiar with this, but without restating a very arduous history, you remember the free conference calling scandals of the mid-late 2000s that stemmed from something called access charge arbitrage. Basically, there were CLECs around the country, well, there were ILECs around the country that operated in small rural areas. And the amount of money that they were able to charge inbound IXCs that were delivering interlata traffic to them was much higher per regulation than would normally be the case in metro areas as telecom defines them. And the way telecom defines metro areas, that almost everything's a metro area. And the reason for that is it was effectively a kind of cost subsidy for the fact that these places are hyper-rural, have lower population densities, low incomes. It's relatively expensive per subscriber to provide service to them. And so the idea was, you know, if you're in hyper-rural Iowa or South Dakota and you're providing landlines to farmhouses, this is very expensive. And one of the ways we're going to reward you is you can charge quite a lot for the small number of long-distance calls that you would ordinarily receive, being such a small place. Well, as broadband and VoIP, you know, propagated, it became possible to exploit this dynamic through traffic pumping. You would put down a server in the operating footprint of some carrier that is based in that territory physically and get a tremendous amount of inbound traffic that under normal, plausible, ordinary kind of organic conditions would never go there by setting up some sort of free conference calling, you know, Jesus line, whatever, and then, you know, you always have 2,000 or 3,000 calls lit up, only you're getting a penny a minute and splitting it with the local carrier. And there was all kinds of stuff like that went on for most of the last 20 years. Longer. And then, of course, the reciprocal comp boom before that in the modem days. To the point of traffic pumping, the number of areas in which you can do this that are still suspended from kind of ordinary metro NECA tariff pricing discipline has just gotten much smaller. So these opportunities haven't totally gotten away from some particularly enterprising actors, but it's just become much harder to do this. And the places where you can still collect substantial access revenue have just shrunk to almost nothing. So, I mean, the market will find a way to arbitrage away any inefficiencies like that, but certainly they were so much more numerous even 10, 15 years ago than they are now. And so you mentioned stir shaken traffic pumping and
Spoofing?
number spoofing. Well, that really relates to the stir shaken thing. Stir shaken has not delivered what it promised, in my opinion, and I'm sure most of you in the room who are familiar with it might agree. There's so much to say on that topic, really, that I don't know that I could really address it in the available time. I'm also not a specialist in stir shaken, so that question is probably best taken to people who are. I can sort of theorize at a fairly general level, but I think some of the implementation, having listened to some talks and panels on this, my sense is that some of the reasons why it hasn't quite panned out are so very implementationally and situationally specific that if you really want to learn more about that, you have to actually get into the nitty-gritty of where and why.
It was a great question. It reminds me, I think Warren Buffett's right-hand man, Charlie Munger, that said, show me the incentives and I'll show you the behavior. Mm-hmm. So that's a shorter version. I'm sure others have said that before. Any more questions for Alex, our PSTN expert historical analysis here? All right. Well, seeing none, thank you, Alex. Hey, you ready to go? Okay. That was a great talk. Just a little bit more logistics reminder. If you haven't got your t-shirt yet, we have 2 more talks, short talks, between now and noon. And then we will disperse for lunch for 1 hour on your own. There's a number of restaurants and things available on the other side, the north side of the facility here, across the street. The restrooms are on the left. We're hopefully, if you did have a chance, grab your t-shirt at that time. If you did register for AstriCon, so we have plenty of those available for those who did sign up. Again, if you didn't, please do come back to our booth on Saturday or Friday afternoon to pick up leftover t-shirts. If you can scan your badge, that would be great too, just so we can double check who did especially when you get your shirt. I know there's a number of other events going on, so thanks again to those who are filtering in from other events. It's a really great opportunity to share some of this knowledge with you from the telephony perspective for a number of years. We're going to get started, I think, at 11:30, so just a couple minutes to grab another snack if you'd like. We do have tables up front in case you can't see them in the back, so it's a place, instead of putting your laptop on your lap, if you'd like to sit at a table, and plenty of power to plug in as well. So, all right, I think we'll get started in a couple minutes with Noah's talk on FreePBX security. And then a brief AI talk, our first AI talk coming up here in 15 to 20 minutes of the day. So excited for Robert's talk here in a few minutes after that. So.
Test, test. Yep.
All right, everyone, I think we'll get started back up here in just a second. So thanks again. AstriCon 2026 is part of SCaLE 23X. My name is Chris May. I'm the open source solutions advocate with Sangoma. If you don't get a chance to talk to me today or tomorrow, I'll be over at our booth on Saturday and Sunday to talk more, the Sangoma booth over in the exhibit hall. We have the conference through about 2 o'clock tomorrow, so you have time to get up and head over there. And then all day Saturday and Sunday, we'll be available with a whole lot more swag. And so if you grab some stickers we've got outside, we've got shirts for people who signed up, like I mentioned. We also have a few pens and notebooks. If we did just dim the lighting a bit, so if you are having trouble seeing it, you want to move up a row or two. I know that's a rather small screen to see, but we are streaming this live on YouTube, so if you want to watch from the very back on your phone, I guess you could stream it. Wi-Fi password is penguins. And then this particular talk I'm really excited about. Noah's talk on FreePBX security vulnerabilities. Made mention 15 we had last year, pushed out 4 last night for publication. It is an ongoing issue, meta issue. We really are taking a strong focus on improving security across all of our portions of Asterisk and FreePBX. In particular, we have some great researchers like Noah who have been responsibly disclosing issues using our GitHub issue tracker security repository. That is the proper place to report issues for both FreePBX and the Asterisk project. You can do so privately. We use the GitHub tools. So if you don't have a GitHub account, I would encourage you, before you file, post something publicly. Please do let us know and give us a heads up. As I mentioned in my talk earlier about 911 dynamic location routing, this is a system that is used for some critical systems to provide emergency connectivity, and we want to make sure that it's as secure as possible, and that requires your help and letting us know about things that you find very important so that we can address them and ask you to come and talk about it. So Noah King, thanks so much.
Awesome, thank you. Yeah, hey everybody, my name's Noah King. I'm a senior offensive security engineer for Horizon 3 AI. So let's dive into a couple of different things. I'll kind of give you a story about what we do and how we work with different vendors. The vulnerability timeline kind of starts off, there was an off bypass vulnerability, not discovered by Horizon 3, we just saw it start trending in the news. And so a lot of times we'll see these articles, Hacker News is a big one, FreePBX servers were targeted by a 0-day flaw, emergency patch now available. When that one came out, there was no known exploit for it. And so what we do at Horizon 3 is we're a cybersecurity company. We have a lot of different aspects that we focus on, but customers can drop us like on a Docker container in their network, and we'll go out there and we'll pen test autonomously all their infrastructure from an internal and an external standpoint. So one of the areas that we focus on is external, what's on the internet, what could be exploitable. And we have a lot of different customers that pay for our services, so we're actively monitoring and trying to find these vulnerabilities before malicious actors do. So when this vulnerability first came out, we started reverse engineering it. We pull down the software, we stand it up in a lab and try to reproduce, or we'll use customer targets if they allow us to probe them. And so as we were looking at it, it took a couple of weeks, and eventually the exploit did come out. We were really close to reverse engineering ourselves, but it was discovered in a honeypot that somebody put on the internet. It looks like a real FreePBX, but it's there to just capture exploits and use that for information for generating exploits. So once that third-party exploit became public, we already have FreePBX downloaded. We were looking for this authentication bypass ourselves, and we actually found a handful of different vulnerabilities that were related. And so we went ahead through the process of reporting those, and some of the timeline, August 26th, the first CVE comes out. August 28th, we start our rapid response, looking for that off bypass, so a couple days later. September 10th, there was finally an exploit found, and so we add that to the Node Zero offering. We also informed any of our customers that had it exposed. We also, at the same time, did some research and we found our own 0 days. And if you're not aware, a 0 day is just a vulnerability that exists in software that currently doesn't have a patch and is most likely not reported as well. So once we published those or disclosed them to FreePBX, in October 14th, there was an advisory for 2 CVEs. One was SQL injections and the other one was a file upload. And then there was a third vulnerability in December 9th that had a patch for an authentication bypass. Finally, on the same day, once FreePBX releases all of their information, there's a safe patch for customers to use, then we publish our information, our research. This allows security teams and companies to find and have a safe way to test for these things. Instead of being exploited or wondering, am I exploitable? They can go and run it in their infrastructure and we're production safe, so we don't focus on taking down their instances. So continuing with the news articles, this is the one that came out by the Hacker News after we reported our vulnerabilities and it kind of hit the mainstream. So vulnerabilities in general in enterprise software, they make headlines often. They attract the attention of threat actors. So there's nation states, there's APT groups, they're all different types of malicious actors. Anybody that even goes on to the internet knows how to find FreePBX on the internet using like open source tools. They can just go grab an exploit and start trying it themselves. Not that it's legal or anything, but rapid response is one of our key capabilities. And so, like I said earlier, we research and analyze 0 days and these end days to find them in customer environments. So this text might be a little hard to read, but I do have a link to all the research, all the blog, and everything if you need to review that. But the first one was SQL injections that we found. In general, if you get a SQL injection, they're pretty nasty vulnerabilities. In this case, you were able to pretty much do whatever you want. You could gain remote code execution on the FreePBX server, or in this case, we're just doing a post to an admin config endpoint for a new custom extension. And if you look down at the very bottom, there's an ID equals, and that says insert into AMP users username and password, and then we're sending hex encoded values. And then over on the right where the frog is pointing, you can see that that SQL injection added a user to the database. They could then just inherently log in. Additionally, there's paths to code execution as well, but the SQL injection in general is pretty bad. These cases, they did require authentication. So somebody already has to be logged in to execute these attacks. So from an unauthenticated perspective, not inherently at risk, but it is vulnerabilities in the system that get patched. Now the next part is that makes it interesting is if we can find an authentication bypass, then we can chain it to the SQL injection. So a lot of times attackers will chain together vulnerabilities. So in this case, this is more the complete exploit chain that does a lot of things. There's 3 different parts of the payload that the frog is pointing at. And so this vulnerability was an auth-type web server. So in FreePBX, you can change your authentication type. You can use web server, there's database, and there's 2 others. None, and I forget what the other one is. But I went ahead and changed that to web server. That is kind of relying on Apache to do some of that front-end authentication before it redirects you to FreePBX. And so what web server requires, I noticed when you turned it on, and I started trying to make requests to FreePBX, it's like you need an authorization header. And I was like, okay, well, an authorization. So I went and started just filling that out manually. The auth header was just, it wanted basic auth. And so there's a base 64 encoded string, and I think I just used like a random admin user, looked at the regular format in a valid session, and then sent it off. And it came back and it just worked fine. So that was the first piece, just passing that authorization header of basic with an encoded username and password. Then I wanted to chain this further, so I had an off bypass. I could chain it with the SQL injections, or I also was just looking through a lot of the endpoint manager, because that's where we saw the previous off bypass was from. So we were looking in that area, and I saw that you could upload your own custom firmware for an endpoint. I saw that that was a file upload. You could just kind of choose any firmware off your local machine. I inspected the request and noticed that if you look at the second frog, it was passing a path. And so it was like TFTP boot, and then I think it's like a firmware folder on FreePBX. I was just able to manipulate the path by doing like a file inclusion or a path traversal, so .. just to back out of those directories, and then place the file in var www HTML, which is where all the public HTML and UI for FreePBX lives, so anybody can publicly browse it. And then the third piece is uploading an actual file. The file is webshell.php. There wasn't any restrictions really to what kind of files you could upload or firmware. So I just uploaded a web shell that executes some PHP code. If you send a command, then it's going to execute the command on the system. So this is chaining together authentication bypass through an authorization header, uploading custom firmware with a PHP web shell, and the var www HTML directly. So it's publicly accessible. And so what that looks like is I have FreePBX on the left, and then on the right side, you'll see we ran the request. We will write different exploits and templates to test customers' environments at scale. So this was the template I wrote, and I just told it to cat etc password, and then I was presented the results of etc password. So from there, we were able to basically get full code execution. We could run any system commands that we wanted to on the FreePBX machines. We kind of had full host compromise at that point. So once we found these vulnerabilities, they were some of the first ones that I reported. I haven't worked with FreePBX in the past, but talked with some other engineers on my team, and they were just like, yeah, you can just submit a report. So I kind of wrote up all the findings that I have. Usually it's just, what is it that you enabled? What are the requests that you sent? What is the expected behavior, and why is this bad? And so FreePBX, as Chris said, they have a public repo where you can submit vulnerabilities. I worked specifically with Chris and Kay Gupta, so I just wanted to give them a shout out for doing the triage, telling me how to update my FreePBX to test their patches and everything, and just working together and coordinating. So overall, it was a pretty successful event just to work with them and all. Some of the references, if you are interested, the full blog, we have an attack research blog, so a lot of our different attack engineers, they will find vulnerabilities in other software. We're known for Fortinet a lot. We have a lot of exploits for Fortinet. We've done things with Cisco, a lot of different other software vendors that are big, especially anything that gives you a foothold into your network and infrastructure. So if you're interested in ever trying Horizon 3 or running these tests to make sure all your infrastructure is secure, you can always check out our product. We have free trials and all. If you need a report of vulnerability, it's easy on GitHub. And then there's just a link to that Hacker News article as well. But yeah, that's all I have. If there's any questions, I'd be happy to answer them.
Yeah, thanks so much, Noah. We got a question back here. Alex?
Thank you. This might be my lack of familiarity with FreePBX or my naivete, but you mentioned there's a public repo to submit what sound like zero-day exploits. So how is the fact that they become publicly available handled?
I help field a little bit of this one, if that's okay, Noah. Yeah. Sure. So the security reporting function of GitHub is a private area. Well, private to us and GitHub. We try to loop in people who, I'll talk about a little bit this more in my FreePBX talk tomorrow. We try to loop in, the reporter obviously and keep them abreast of it. And then we also work internally in discussion about the solution. And so the publication comes about later, and that is just the description at the top of the project. Then all the other work that's done and subsequent comments as we move along, and private code forks remains private. I believe the fork is actually discarded when the issue is published entirely, but the comment history is there. And so we move some of the critical sections of the POC out of that top level description and summarize it and shorten it for users. So we have a few steps that we kind of move through in this process. Because we do have a policy, and we we try to adhere to 30-day analysis, 30-day for a fix. I'll talk about it a little bit more tomorrow, not to steal any thunder from Noah, but it was great working with you. Thanks again. And so if you do have some more questions, I think you'll be around for a little bit today, and hopefully we can connect a few more people who have questions about this or have found issues and how we go about it. So.
Yeah, for sure. And I'm on LinkedIn, so if anybody wants to connect, feel free to reach out. Always happy to answer any questions and everything. So. Yeah.
Great to hear about the honeypot too. We'll talk more about that as well tomorrow. So, all right. Thanks so much, Noah King. And next up, Robert Keller to talk. This will be actually, I believe, our second AI talk. I forgot that Horizon was .ai for the domain name. So 2 AI talks in a row at some level. And just a brief minute here on Robert, longtime contributor to FreePBX over many years, has developed a number of different solutions. I think we're gonna really enjoy taking a look here at what he's developed now for a little bit more natural way to perhaps configure your phone system. We talk about this voice AI concept and what that looks like practically for end users, but it does seem to be that voice is a very common way to configure these systems. And we can kind of extend, that to configuring the phone system that you're doing voice AI with. So just kind of touching on that talk a little bit as we get Robert situated here. So.
Hello, 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 hello. Can you hear me?
All right.
All right.
Robert Keller's talk on FreePBX AI.
All right, so this isn't going to blow your minds or anything. I go through a lot of thought processes. I go, what if, right? And so just the thought process here was I previously worked in support at Sangoma, providing support to FreePBX users. And one of my fantasies was always, what if when they called in, we could intercept them, much like a chat might intercept a chat with a chatbot, but in voice, and allow them, once they've authenticated, to make common moves, adds, and changes before even reaching a support agent. So a little bit about myself, 30 years of communication experience. I started, believe it or not, with Asterisk at Home, if anyone recalls that back, I don't even know what year that was brought out, but that was my first insight to it, then FreePBX, and then on to my career at Sangoma and so on. I'm an Army veteran and I'm an AI enthusiast. So again, this isn't going to blow your mind. It's really just a thought, hey, what if I could do this? And just as an aside, my workflow is I use Claude Cowork, develop in Python locally, and then distribute the code once it's, debug and distribute the code. Works pretty dang well. I'm pretty happy with that, that bit. So why would I do this? Because a lot of end users, they're not really super familiar with FreePBX. Maybe somebody put it in their ID department and now they got to change the name on an extension or something. So it's not exactly easy. It's a complex UI, there's config files, slow iteration, and then a lot of times, not this crowd, but a lot of times for users, they need somebody, an expert, to go in and make these moves, adds, and changes. In my opinion, why not just type it? And just as an aside, I didn't have it ready to show you, but I've extended it to voice using 11 Labs, so I can just tell it to do these things as well. So for example, if I just want to add an extension, 1005 for John Smith, type it and it goes, and so on. There are some limitations with GraphQL and FreePBX, which I'll talk about in a moment. But that's basically it. Natural language commands that go to FreePBX, make the change, apply the config, Bob's your uncle. Essentially, this architecture for this thought exercise is, on my local machine, I've got the Python script, and then that's where I do the input. Claude AI interprets what I'm saying, what my sentence is, and converts it into what needs to be done in FreePBX. And then the FreePBX, and I know MySQL is MariaDB, but hey, the GraphQL API writes it all through an SSH tunnel. It's pretty straightforward. I want to also point out at the very end of the end slide is a couple of QR codes. I wrote up a guide on, you can go home and do this yourself if you want. And so they'll be up there. I'm only going to leave them up for a month, so if it's of interest to you, grab the QR code, just download the HTML if you want it. So here's the thing about GraphQL. The things that do work is I can, add and remove and edit extensions, ring groups, and I can read any object, but really I'm kind of stuck. I can't do any IVRs or inbound routes or anything like that. Again, this is just a thought experiment, although I have been given a few tips on how I might get there with the rest of the config. We'll see it over time. I think this is a little demonstration. This is going to be a little tough to see, but the long and short of it, in the upper right is just the FreePBX CLI, and the lower right is my commands, local commands on my desktop. And here I'm going to add, this is just a video I recorded, add an extension, natural language, add an extension for whomever. There's other things I could say, I do point with voicemail, for example, right? And so it's going to do a deal. It's reaching out to Claude. I don't know if you can see it or not in the lower right, but Claude is interpreting. And this is real time. Just to give you an example of how long this takes in its current iteration. There it signifies, okay, I'm doing the mutation. In the upper right, you can see the CLI is fixing to sprawl around a bit because it's applied the config. And then if I go check FreePBX, Bob's your uncle, extension 1000 was created. Not mind-blowing, but I think it's kind of cool. Now in the lower right, I'm typing in I want to create a ring group. And I can decide at this point which extensions. I just said all extensions for brevity of this presentation. It's analyzing my query. And then it's saying, do you want to really do this? And it's like, yep, go do it. And it's writing to FreePBX, and you'll see in a moment the CLI will spool about a little bit. And then if I go check the GUI, we can see that ring group 300 is there. And if I was to dig into it, you'd see it had all the extensions that I have on there. That's basically what it does. Again, I'm extending a little further. One of the fun things about this project is on my desktop, I've got a folder that has all the mechanisms, the SSH mechanism for connecting to FreePBX. And now I can just start writing projects that use that mechanism to connect, and the APIs I've already, connected, and do other things. So that's, oops, I don't want to do that. Anyway, long story short is there's a little bit of safety net built in there. It does a difference preview. It says, okay, you had this, now I'm going to do that. I have to explicitly type in yes, because you don't want it just willy-nilly doing things. Something you don't see, but in the background, every time I'm doing changes, it's making a little backup for me so I can go back if I screw up something. That's the rollback, auto backup and rollback, and GraphQL validation, and then auto reload. And by auto reload, I mean it basically does the apply config in FreePBX and then page refreshes. Some of the commands that you can get away with today, add an extension, list extensions, delete extension, what extensions do we have? I mean, it'd just be natural language queries into the FreePBX system. Same thing with ring groups. I work for a company called TechMetric. I left Sangoma to go to TechMetric, and we provide shop management software for independent auto repair shops. And so my role at TechMetric with AI is to empower our staff and also to bolster our ability to support our customers. So, right now, we've used Intercom's Fin app to be our chatbot, which I got to tell you, I was pretty skeptical, but we're having great results. Next step up, Agentic Voice AI. That's the bit about when people are calling in, I want them to be able to do some things before they even reach a support agent. It frustrates some users, but we're actually getting, believe it or not, pretty good response. If they can just take care of a thing and not wait, customers seem to like that. Lastly, this will be voice max over the phone. In our shop software, there's lots of little different settings you can tweak. I will, it probably won't be this year, but I will eventually have it so that an authenticated user, either by voice or chat, can actually make these changes in their system. I saw a really cool Google demo of these things happening, and then basically your app in the web page, it's a SaaS product, it goes to the page and allows you to make, guides you through all the thing dynamically. And I'm going to go there with it. Pretty cool stuff. The last thing is I mentioned that it's extensible. Now that I built this project to do natural language query, well, within that folder structure has all the authentication mechanisms, API connections, and so on. So I can extend it. One of the things I did is built a, hey, what's on this FreePBX query? Now, I know someone's already done a visual dial plan. Here's the thing, what I'm not going to show you because you wouldn't be able to read it on the screen. If I scroll down in this display, it has audited the FreePBX system to see where the gaps are. Like if I made a ring group but didn't put any extensions in it, or an inbound route that doesn't go anywhere, whatever, it audits the entire FreePBX system to determine where your gaps and where you may have setup to do. And I find this would be particularly useful if you're a FreePBX support person and you got a new customer that has an existing system. Instead of digging through everything to find out what the dial plan is, run this query on it. It'll analyze the entire system, visually outline what the existing dial plan is and where the gaps and problems are in it. And I'm just going to keep extending it from there. It's I have too much fun in Claude Cowork, to be honest. And then last thing, as I said, that is the presentation. Here are some QR codes. The one on the far left over there, that's the project itself. The one in the middle is that visualization thing I showed last. And just for shits and giggles, TechMetric is the last QR code in case you're curious where it is I work. So, questions?
Thanks, Robert.
No? Okay, thank you very much.
That was very informative. Great use of the several FreePBX modules. Right, we have about right on time, noon, an hour for lunch. So please eat something. I think there's an apple if you just want to grab that on your way. A few other beverages we'll have back after lunch. So some after lunch coffee, tea availability. We'll get back started at 1, Desperately Seeking Susan, an interesting talk about some interop with the French government and Asterisk for a project for the French government. So that'll be at 1 o'clock. We'll see you back here. Thanks so much.
Yeah. Okay, we're going to wait a few more minutes for people to come. Yeah.
We can wait a couple more minutes to get back started here. So if everybody, some cookies came in the back and some chips, refresh coffee, and there's tea. So feel free to grab a refreshment. And some water as well back there. So, and then if you were curious, the restrooms, they are located through the double doors when you get out and make the left. I think those are closed now, but it's still back a little further that way. So we'll get started in just a couple minutes.
My name or my first name? Alexandre. Alexandre. Alexandre, but you can say Alexandre. And Moret Bourny. Moret Bourny. But do your best. Bourny. Bourny. Yes. B-O-U-R-N-Y. But you can just say Alexandre. Alexandre, it's okay.
All right, I think we're going to get started now. If we can mosey on up. Thanks again, AstriCon 2026. Our next presentation after lunch from Alex. I'll give the courtesy of not trying to pronounce his last name. Desperately Seeking Susan, fun asterisk project for translations on behalf, I believe, sponsored by the French government. So if everyone can tune in over here, that'd be great. And again, our live stream on YouTube, if you can't see in the back, you can hold up your phone and watch that from that's the SCaLE Linux live stream. There's a number of live streams for each room on YouTube. So if you go to the SCaLE website and then click on their YouTube, that's probably the quickest way to find the live streams. And afterwards, everything will be published and cut up into little pieces so that you can watch it presentation by presentation. A little bit more focus on the slides. We have a couple separate feeds for slides and then for the speaker themselves. So again, Alex, over to you.
Thank you very much, Chris. First of all, who is older than 45 years old here in the audience? Okay, so those one may know this movie, 1984, first movie with Madonna and the Arcade Sister. And I would like to apologize because this talk has nothing to do with the movie. And you won't see nor Miss Arcade or Miss Madonna on stage today. But it was about finding the right person at the right time. Who am I? I'm Alexandre Moret-Bourny, but as Paul Simon said in the song, you can call me Hal. I'm 56 years old, I'm French, so excuse my English. I have 3 plus 2 kids with my wife. They are old now. It's a huge family, like a small business, having 5 kids. This is my 10th AstriCon in a row. First one was in 2016 in Phoenix, Arizona. I'm an IT and telecom enthusiast since I'm 15. I was born with a ZX81, for those who remember, it's a small computer. And I'm also a private pilot. And sometimes a singer, but that's another story. Don't ask me to sing a song today. Back to business. I'm the CEO and founder of Uris and Colibri. We established a company with my partner, Hélène, in 1992. We are located in the south of Paris, 20 kilometers away from Paris. We have more than 50 employees. If you come to Paris, feel free to ask me. We have some good coffee. And our business is answering service. It's a specific part of call centers. I know that in America you have answering service company. In France, it's a very specific niche. We receive call mostly for doctors and clinics. And we are operating on this industry in two different ways. The first one, with the brand Uris, it's a call center. We have around 40 to 50 employees on that brand. And we are answering live calls, incoming live calls from doctors, clinics, small businesses, customer cares. We also call that BPO. Since the beginning, as I said, I'm an IT enthusiast. I was born with a computer in my hands. And we create softwares for the answering service industry. Basically, of course, we are our first clients, but we also provide our softwares to our competitors that make us in a very specific position on this market. If we talk about metrics, with Colibri, we have up to 1,800 agents, human agents, because now we have AI agent, of course. We are handling 80 million calls a year, mostly inbound, running over 150 different asterisk. I love asterisk. 20,000 different DIDs on French, German, and Belgian markets. And our system can go up to 2,500 concurrent call and up to 1,700 incoming call in just 1 minute, thanks to OpenSIPs. So, let me talk about the project. We have one client that, on behalf of the French government, the French government changed the rules to ask for the politic refugee status. You know that France is known as the human rights country. So everyone who asks for the refugee status can have it, but he has to fill some forms and meet some people and blah, blah, blah. Back in the past, it was a long process, and the French government asked to reduce this process. And of course, when you come from Belgium, but if you come from Belgium, you don't ask for the political refugee status in France. But if you come from a country where you don't speak French language, it can be quite difficult to fill the form and so on. So the point, one of our clients, which is a translation company, was commissioned by the French government to be able to provide a translator in 125 different languages to one government agent that having in front of him someone who asked for the political refugee status. We have 125 different languages covered by more than, 600, 700 different translators. And that in just 5 minutes. So it means that if you go to this government agency and you ask to speak to someone and fill a form, and you are coming from Sri Lanka, for example, and you speak only Tamil, the agent have 5 minutes to provide you a Tamil translator. So let's play a little game. And back to when you were at school, we have different languages right here. Can you tell me this country flag? Spanish. Who said Spanish? Who said Spanish? I heard Spanish. Yes, this is a candy for you. Okay, this was a nice one, an easy one. This one. Ukraine, great. Whoops, sorry. I don't know if it was a good idea to put Ukraine and Russia in the same place. Hindi? Who said India? India. Who is India? Okay, David. Yes, last year you were the one to send me some candies, I remember. More difficult? Yeah. Ask Mr. Trump. This is the Tajikistan. So people talk the Tajik. This one is for me. Of course, maybe you know, what? Nope, nope, Cambodia. Who said Cambodia? Great, thank you, sir. Okay, two more. A little bit difficult. This is Romania, and this is Romania, sorry. And, sorry, the one before, it was the Philippine island, which have a lot of different languages. And it's the Tagalog. Who ever heard about the Tagalog? Thank you, sir. Do you want a candy? No? And the last one, of course, Russia, but we don't have a lot of people asking for the French citizenship coming from Russia. Well, the process. So, as I said, when a government immigration agency requests a specific language, it calls the ID number, it gets in touch with an agent, asks, I want someone to translate Tagalog, and the agent just asks a robot, let's call it a robot, to find a Tagalog translator, after he qualifies, of course, the request. This looks quite simple. Thank you to Asterisk. I will show you how it works under the hood. Our two skills, our two subsidiaries, the first one, the service company, Uris, with the agents, and the second one, the software company, Colibri, all together we were able to face our clients' requests. At Uris, as I said, we have 50 agents working 64 hours a week. And we have an average queue duration before pickup, which is under 18 seconds. Nothing about call centers as we may know. You know, when you call and you have the music on hold for minutes. On the software side, we were in need to build the UI for the agents, which were part of a business. Setting up the call flow, I will demonstrate to you. And just keep in mind that for some specific languages, Russian, for example, or Turkish, we have more than 80 different translators that can speak that language. So, how does it work? First, when the agent asks for a Russian translator, we will send some batch calls. We will extract the 80 plus different translator, then send the call in batch of 10, wait for one of the translator or many translators to answer the call, redirect them to an IVR, and ask the translator to press 1 to accept the mission, and then we stop all other outgoing calls and transfer the translator to the agent so we can put the translator with the government agency. Quite simple. So we have the agent who send the call. And of course, if we have, let's say, 30 different translators and the first 10 doesn't respond, we stop them and try another batch of 10. It's quite simple. So when we have the first one to press 1, we kill all the other calls, send the call back to the agent, saying, okay, I have a mission for you, okay, and put the call through. Quite simple. But it leads us to different challenges. Well, first, what's involved in this mechanism? The first one, obviously, asterisk. We build a call controller that is in charge of sending the call, manage the call, clear the call when someone gets in the IVR, and so on. We used AMI. I know Chris and Josh, you told for years to stop using AMI and the benefit of ARI, but AMI is dead. Long live to AMI, as I said. Well, we have a long expertise on AMI. We use it a lot, so it was common sense to use that kind of technology. We also used asynchronous AGI for signaling during the IVR. We used an IVR, of course, for the mission confirmation with some specific parts and tricks, and mostly the group variables, because as we send a lot of calls, and sometimes we had 2 or 3 different translators getting in the IVR at the exact same time and pressing 1 at the exact same time and getting to the agent, which was only in need of 1 translator. So I will show you the dial plan after that and how we used the group variable. So the call controller, we have the agent. The call controller is exposing some APIs, basic APIs that we created to create, delete, list, get the status of a job. And basically, a job is what? Is requesting a language ID, giving the device ID of the agent, the number of simultaneous calls we want to send, and some different parameters. We have AMI to originate, to list the channels running, and to hang up the calls one translator accepts the mission. So asterisk, of course, is sending the call. And like on the previous chart, when we get in the IVR send through the asynchronous AGI the status, is it answered, does the translator press 1, etc., etc. So let's get in the IVR. Sorry, I tried to put all that in the same page, so maybe it's a little bit small. It's a classic. Who made an IVR with the asterisk dial plan? I guess a lot of people, right? Okay, it's quite basic to do. And it's as basic as it's just one level IVR. But as I said, we used asynchronous AGI to signaling the call process in the IVR to the call controller. And the main problem we faced was, well, first, we had 2 problems. The first one is when you originate a call, you know that AMI is asynchronous. So when you when you ask to originate a call, you don't get the answer right now, and you won't have the channel name in response to the originate. And the problem is that sometimes we had some calls going out, and at the same moment, we had one translator pressing 1, but we didn't know which channel to clear. So that's the reason we used the core channel, I don't remember the name. And the second part, the second challenge we faced in the IVR was that two translators can come in the IVR at the exact same time, as I said. So we have these variables. I put it in the bottom left. It's the job ID, okay, that we have on the channel. And this job ID, we use the group variable with the name of the job ID, and we checked how many channels are in use this variable. So as you can see on the dial plan, if we have a count more than one, it means that we already have someone in the IVR, and we kill the call. Well, we don't kill a call. We said, sorry, we already have someone to fill this mission. So 1 year after, because we started this project 1 year ago, it was, at the beginning, it was just one agency in France. There is 50 of them. We had more than 1,000 requests that were successfully handled. And 99% of those requests were processed in less than 5 minutes. So mission accomplished. We have some future announcements that we plan. First, instead of hanging up brutally the call when one translator press 1, instead of hanging up all those other calls, we would like to redirect them to a specific sound file saying, we are sorry, you came too late. And for the moment, we use our translator on a random basis. And this is something we need to figure out with the French government. It's how to, do we need to ask, if we have one translator that answers very fast, do we need to put it in the top of the list? So the draw point will be that it's always be the same translator, or do we have to use a round robin? So we need to enhance the rules to select the different translators. And the last one, yes, sometimes because we send calls to some mobile phone, and sometimes we get into the voicemail. We have this wonderful module in Asterisk, AMD. This is answering machine detection, I guess. That works quite good. So maybe we will use it in the next future. So that's all for me. If you want to reach me, feel free to send me a mail or contact me on LinkedIn. And if you have a question, I'm here to answer. And please ask your question slowly, because thank you.
All right. Thanks very much, Al. Yeah, that was great. I appreciate the dial plan examples. No hard feelings on AMI, none at all. We'll have to ask Josh about that tomorrow. He might have a little bit more to say, but personally, big fan of comp files. I had a few in mine, and if you've looked at the FreePBX source, there's an awful lot of that AMI going on. AGI as well. So there's a question back here. Yep.
Well, it's more of a comment on the routing for the agents. One thing that we ran into and we created in one of our systems was a priority and a wait. So priority is like when you're at a deli and you have the lowest number, you always go first. Mm-hmm. But then if you have two people that have the same number, if you assign him a weight of 50 and him a weight of 1,500, he's going to get far more calls. Mm. But in working with it in call centers, you need to make sure that both mouths get fed, but we may want him to get fed twice as many times as he does, based on whatever's in their history. And that brings me to my next question. What you're describing is a ping post lead generation system. Have you thought of doing something outside of Asterisk in another system for whatever work they're doing so that you can keep track of the agents, route, and they can claim it there without actually initiating phone calls?
I'm not sure I get your point. Can you rephrase, please?
Maybe, let me help. So you're asking about external application interaction for the agent to self-select their position with history.
Well, it's not about the agent. It's about the translator. The agent is getting a call.
Yeah, I think I misspoke. I think you meant the translator. The
Okay.
translator seizes the call externally to the queuing mechanism.
Exactly.
Okay,
exactly.
very well.
So when we send the, well, at the first place, when we get the call from the government agency, it goes to an agent among the 50 we have, using a regular queue. It's a homemade queue, but it's quite the same as the one we have in Asterisk, right? This is basic. The problem was to, well, the main goal of the mission was to find a translator in a very specific language in less than 5 minutes. An external one, which is a freelancer, so they are not employees waiting for missions to come. So that's, and 5 minutes, this is fast. This is very fast. So that's the reason.
Can I ask a clarifying question? So the agents then are remote, taking a call on a cell phone?
They can be, yeah.
Very well.
Oh, you're talking about the translators?
The translator,
Yes,
excuse
yes,
me,
yes.
yes, the translator.
Yes, absolutely. We have translators all around the world.
Oh, very good.
Yeah, and we also have some that we call on soft phones or WebRTC, and yeah.
So they have a variety. Maybe that's the issue then with the option of the external. It's a matter of they're not running a dedicated app. They're just answering the phone
Exactly.
and translating, not a standalone headset desk. Where that might be the issue. Yeah,
Absolutely.
Sure. Well, that's a great way to leverage the PSTN. I like
That's
it.
another use of the PSTN.
Yeah, yeah. Anyone else have a question? Oh, here we are.
I have more of a human factors question. Given that you support 125 languages and you have translators supporting all those languages, how does the agent know what language is being spoken to request a translator?
Because we have a database. I don't know if I get your question, but we have a database with different translators, the different languages, and the skills for each. So we know that Mr. Smith, he speaks Russian and, I don't know, Hindi and blah, blah.
Oh, just a second. Oh, so we can catch you on the mic. Yep, is that all right? Here you are.
It's the agents are the ones that get called by the French government. So I assume the French agent that is making that first initial call knows I need this language, and they communicate that
Absolutely.
to the agent, and then that goes to the database and knows which
Absolutely.
language.
That's correct.
A couple humans involved in the process. So
Yeah, I'm surprised that no one mentioned the AI.
well, we just assumed that these were AI agents. These were actual human beings. Al, come on.
Well,
yeah.
that's a question to replace the translator by AI translation system, of course. But it's all a question about liability. We are talking about refugees, about some government stuff. So that's one of the main reasons we still use some real human translator.
Yeah, confidentiality being a key component, privacy, very important functions of this kind of system. Excellent. Oh, another question?
You said about AI, like using AI to translate, but what about using AI to just replace all your agents?
Because I'm French.
Moi aussi.
You are?
I speak French, yeah.
Okay. And, maybe it's the main difference between Latin people, French, Spanish, Italian, and German, American, English people. We are very, very in human relationship, empathy, and so on. My point is AI is very good to enhance human. It's not here to replace human.
Okay, but all your agent is doing is just routing the call to the proper translator.
Yeah.
The foreign government can go in an IVR and be like, I need language 16. Okay, that's Russian, Indian. bypass your agent or go to you know what I mean? Yeah.
Yes, absolutely. You're right. 99% or 97% of the calls are for new mission. Okay, I have this Pakistan guy in front of me. I need a Pakistan translator. I called. Sometimes during the mission, because the translation mission can last 45 minutes, 1 hour, 1 hour and a half. It's very long calls, right? Sometimes the call drop because of not PSTN, but mobile network. And so the translator called back the agent, and there is some specific treatments of those calls. So we still need to have this human history to correctly handle all the mission from the beginning to the end. But you're right, that's one of the enhancements we're working on.
Great. Any other questions? Okay. Oh, hey, sorry.
I love there is a lot of questions. I was not expecting that.
More of a question/statement. So I was just curious, so you do hang-ups, right, of all the translators that are not needed, but then you do batching, right? So you do these like 10 at a time. Have you thought about like redirecting them back into the pool since you have their attention anyway?
Yeah, that's part of the enhancement I talked about, because it's a little bit brutal, right? When you get a phone call and when you are ready to pick up the call and suddenly it hang up. So yes, we're working on that. The very first point of this mission, of our job, of the project, was to provide a translator in 5 minutes. Now we are trying to make things better.
Like optimize the flow,
Yeah, that's it.
Makes sense.
Great question. Anyone else? Oh, there we are.
All right, I'm going to assume the translators are being paid
of course
by the minute or whatever. So, are you in charge of the billing for that? Like, is that handled by your system? Is it handled by the government system?
No, it's well, there is two sources. The first one, it's there is a cross-checking. First of all, we have the list of the call we transferred to from the agency to the translator, and we know which translator, how long it lasts, and on the other hand, the agency is keeping track of all their requests on their side. So at the end, our client, which is the translation company, they do this cross-check to bill the French government and to give the money to the translators.
They're not just there to chat for the day, I guess, yeah. Volunteers, yeah. Great, good question. Anyone else have any questions for Al? Okay, that was a lot of great questions. We'll get started with our next speaker. Thanks again, Al.
Thank you very much.
So we're going to get Dan set up here. Hey, Dan, didn't recognize. Oh, nice beard. Yeah, Dan, to speak a little bit about ARI. Just to, we talked about, Al talked about AMI, the Asterisk Management Interface. That is a TCP connection, typically over 5038, and has been around for a number of years in Asterisk. It is one great way to interface spool calls, return status of different channels in your system. Also mentioned then was a little bit of AGI, the Asterisk Gateway Interface, which is similar to a CGI, what you think of like an Apache web server if you're new to Asterisk. And so that was a little bit earlier, I believe, in the history of these interfaces. And similar, though, read-write protocol that a lot of Perl clients and things of that sort were written. And then moving on to the Asterisk REST interface, which is a little bit more web-friendly GraphQL type solution. So this is sort of some of the evolution of different ways to talk to your Asterisk system from other systems. And there have been a lot of improvements and changes and things. So I think that Dan is going to teach us about some of those in a minute. Oh, yeah, that's great. This is good. Yeah, this is great though. Yeah, I think we'll just make sure it's set up here. Looks good on the screen.
Okay. Yeah, I think it's good, huh? Yeah.
All right, thanks a lot again, everyone coming to AstriCon 2026. Dan Bogo presenting here about real-time billing using the new bidirectional ARI. Dan, over to you.
Thank you very much. Thank you for having us here. So, just few words about company paying for my trip here. So we are a company located in Bavaria, Germany, with back offices in Romania and Albania. So first thing we choose a spot is the beer should be good and accessible price-wise. So all these offices, they meet perfectly the goals. Then we got over 19 years of experience now with architecting old-time, old but gold server-side solutions in VoIP environment, and not only nowadays. We have in the past platform implementation covering both wholesale as well as retail. By now we understand what real-time processing constraints are and how serious are live outages. Thinking of all this together, putting all this together, this is how our billing engine came. We call it nowadays a real-time enterprise billing suite because it's not anymore just a billing engine. It's a set of services or subsystems, how we call them, which help you with what we think everything what is missing already in your network. Out of concepts we put in is that it should be pluggable into existing infrastructure. So you should not be forced to route your traffic to the box we choose, and you should not be forced to do things in the cloud when you're not willing to. So you can either host it on your side on premises or to the hosting provider you prefer. It should also be able to accommodate new components into whatever ISP, ITSP network, and it should be non-intrusive. So in the end, the administrator should be the one choosing the architecture and choosing the demands of his network. It's all open source software. It was born back in 2010. And the first sources were published in 2012. Full sources are available on GitHub or on our GitHub repository, 100% Golang. So when we started in 2010, Go was like weekly released. So it was quite an adventure to start with. And that makes us one of the first Golang projects around. We have today, I think, more than even 500,000 lines of code and lots of consideration for community contributions.
We got 3 branches indefinitely, all supported. So V010, which is stable conservatory release. Working with telecom, you know what that means. Then we have the master, which is also used in production. And then we have, but it's more like where the new functionality comes in. And 1.0 which is our vision for the future. We are performance oriented as a billing engine. Most of the time it becomes the bottleneck of one's network. So we need to be fast. For that, we have built in our advanced caching system. So if people are using, I don't know, NoSQL databases like Redis for caching, we use Redis as normal database. So we have our own layer, which is built in the process itself, where the caching occurs. So that's written by us. So this is what it makes things go or work faster. It has some interesting concepts built in. So LRU, list record used. So we keep only hot data in the cache. And also TTL, so you are able to say how long time the data should stay cached. Then all the processing is asynchronous. So if you know Go, you know that it's harder to synchronize the Go routines, what they call, than putting them asynchronous. So it's natively asynchronous. And we have included an API load balancer if you have to grow faster than what one engine can do, which is something we have estimated about 7,000 to 10,000 requests per second per engine. And of course, it depends on real life problems. And we have in-memory database implementation, our own. So if you want to replace Redis, although nowadays they came back to being open source, you can still do that with our own database. And we also have, same like Redis, on disk storage support. It's very similar concepts. The architecture is modular. It's cloud ready from back the days. Microservices with rich set of RPC APIs. So all what we are doing, it's API. And it's easy to enhance by rewriting specific components. So if you are unhappy with the licensing, which is AGPL, the most modern version of GPL, you know, Redis went there due to the fighting with all these cloud providers. So we learned from them before we had their problems, and then we directly went to AGPL. And if you want to rewrite one of the modules bounded to AGPL, you can simply replace it and put your APIs, because all it takes per module, there are like 5 APIs which you have to support. So write your own modules. You are not bounded anymore to GPL. Test-driven development, again, we usually start with test and then we write the software. And we have over 10,000 tests as part of the test suite. They all run with GitHub Actions, so whenever we get a PR, we already know if it's compatible or not with a stable software. So you can always see that before accepting the PR. In terms of functionality, I tend to sound like I'm a marketing guy, but I'm not at all. So I'm purely a core developer of the software. The reason I'm talking about all this functionality and about the software is, first of all, I'm very proud of what the software does, and the second, I'm trying to teach you what it can bring to you. So this is why you see all of these things highlighted. So it's an OCS. This was the first target of the software, so online charging system. We are popular in mobile networks, so including the latest with eSIM stuff and 5G and all this big, let's say, trends. Then it's also an offline charging system, so you can charge, you can bill your offline CDRs, which you maybe receive from your suppliers, from I don't know, any source of CSV files, for example, XML, whatever, you can charge them using CG rates. It was multi-tenant from day one, so you can do white labeling platforms, you can implement stacks of different billing runs. Then we support multiple databases. Then we support real-time configuration reloads, because you need to do that when you are changing your mind regarding your functionality. It has a rating engine with derived charging. This derived charging, it's good because you can charge an event like a CDR multiple times. So you can do it for your distributors, for your suppliers, and for customer, which is end customer of your distributor reseller. Then we support A number rating. Maybe here is not a big thing, but in Europe, it's a feature you must have as a carrier or as a wholesale provider. Then we support account balance management with bundles and dynamic prepaid. So like all these mobile networks, to have bundles of data, bundles of SMS, actually any kind of bundles. If you want to sell cars together with your telephony, it should be possible via these bundles. Dynamic prepaid creates accounts on the fly. So if you want that anybody could have a test account bounded to his CLI of, I don't know, €1 or €5 or $5, you can configure the system. So if it doesn't recognize the CLI as being a local account, it should create the account, but limit it for $5. So this is what Dyna Prepaid does. Then you have sessions or event charging with balanced reservation. So it's the full prepaid mode, like chargeable every 1 second to 5 seconds, whatever. You have the heartbeat for your billing, same like mobile world. And you can do refunds, because these are always charged in advance. So for example, if you're charging at a 5-second interval and he's only talking 3 seconds, we will refund back in the end. Then we have what we thought it's fun to implement back then, still shaken in the billing side. Actually, what it does is it grabs the information from the VoIP switch in this case. It compares it to stir shaken hashes and all this security stuff around it, and it's able to return back if it's authenticated, the CLI or not. And what it does also is that you can also use it to generate your own stir shaken header. So it's unusual, I know, but back then when we have implemented, most of the switches did not have it. Now, in the 1.0, we were still arguing whether we should keep it or not, because not many are coming to the billing engine to implement stir shaken. But there are still, especially in the mobile world where the switches are pretty old, there could be still a nice enhancement to have during authorization phase, because we need to anyway authorize the call. So the call, it's coming to us before going to routing It's coming to OCS. So it feels like a native place where you can do stir, shake, and authentication, and a native place where you can still reject the call if the CLI is spoofed. So I guess we will still keep it because we don't pay for development anymore. And then CDR logging as normal CDR server. So I'll explain you how we create CDRs for Asterisk. Actually, we steal the CDRs. We can also rely on Asterisk CDRs, but we can also generate CDRs via ARI on the fly. And for that, we had to use some tricks, which is what I will talk about it. Then we also support rating queues. And what are these rating queues is we can get the CDRs in a real-time push to us, and we push like forward, same in real time, towards whatever message bus or database of your choice. Popular should be, I don't know, Kafka or something, where the Asterisk CDRs can be received in real time in Kafka, already built. So it looks like they are coming from Asterisk because they finish by when the call is finished. Few milliseconds later, you have them in Kafka already built, which is kind of cool because you pay almost no penalty other than configuring, so hard to configure CG rates, but you have no other penalties to get there in real time. So you don't have to wait few minutes, like batches of 15 minutes or 1 day to get your CDRs to your customer. And also the number of interfaces for a reader or exporter also offers you the possibility of having these CDRs from Asterisk distributed in many places in the same time. So you can send them to your distributor, and you can also store them to your own queues. And some examples you have here, AMQP for RabbitMQ, or SQS from Amazon SQL, CSV, XML, whatever. So the normal ones. Then what we also do is, doing billing, it becomes again natural to do fraud detection because we work with money, so we know when something looks abnormal. And we also can do automatic mitigation. So if we detect fraud, then we can shut down, we can go so far to shut down the account until, and maybe inform the NOC. I don't know how many levels of escalation you have. Inform the NOC that there was some probability of fraud, and we have shut down the account, so NOC can review it and unlock the account. So if things are happening in the night, you are not anymore exposed. There can be some customers shouting that they could not use the system, but better to have the car with brake first before the engine, because it could be that the damage is more serious later. Then we also do, again, very compatible to billing, LCR, because we have access, so it's LCR with pricing, it goes hand in hand. Then we do LCR with quality of service, having access to CDRs, you have access to all the PDD or average call duration, all this fancy old style, which are still better than looking on the latency and jitter of your network, because your customer is the best tester, and this still is since always. Then we also can do LCR over bundles. There are suppliers offering particular number of minutes with special prices, like 10,000 minutes to specific destinations with 1 cent, and then they go to, I don't know, 2 cents or whatever. So you need to know the QoS, and we also support pattern monitoring. So you can do also the LCR based on call duration and not only per minute, because it's important if you have between peak and off-peak a call, and prices are changing. Your average call duration is 3.5 minutes, and then you should get the proper feedback from the LCR system. On LCR, we also support number portabilities and all this other stuff. And we also support dynamic pricing imports with templates, diameter, radius, for the mobile worlds. All these protocols are important. DNS, everybody thought DNS is dead, but I know switches doing DNS queries for their routing, so enum routing. SIP server, we even have a built-in SIP server where you can send your calls from your Asterisk, for example, and get redirects based on LCR. So this is another type of project. Then resource allocation controller, and these are dynamic resources, so you can count the so-called virtual channels per destination, per time, so you can limit things in the switch via this resource allocation controller. So you can have, I don't know, 20 simultaneous channels to US mobile or to premium or whatever. So during this and this time, so these virtual resources, they kind of give you the opportunity to make these old static limitations of your switching, and very useful in commercial, like to monetize your business based on various tricks you want to do in your network. Then API server with support some special serialization of Golang, which is GOB. Then JSON RPC. Then HTTP JSON support, then built-in high availability and dynamic partitioning, API capturing and analysis service, and then clustering, all this. As soon as you grow, they are all in there. Then, of course, we are developers and we are passionate about adding new software. Then, in terms of appliances, what can you do with the software? So, online, offline charging system, it's the default one and original product. Then, there you can implement very complex rating. So, this kind of charge the first minute as a whole rounded with specific amount of monetary. And then if you want, you can go to charging each nanosecond differently in a call, if anybody is crazy enough to do that. Because at some point, everybody was just complaining that most of the switches were doing milliseconds, and they wanted also to have milliseconds. So we offer nanoseconds, and nobody wants to do it. So it's, it's hard to find the middle way of what are the limits, because as soon as you go more, everybody realizes that they want less. Then, sorry if I sometimes sound a bit off sync. Where I'm coming from, it's like middle of the night more, so it's 1 a.m., 2 a.m. So I'm still trying to make sense where I am now. Great. So as part of online charging system, we have the unlimited bundles, so you can add as many bundles as you want. We have the CDR server and high number of interfaces, all what I showed you before. Then as routing server, separate routing server, you have flexible routing strategies. It's a very advanced routing server. Then as I told, number portability and complex rating, bundle support, and routing based on QoS. So you can choose, and also failover. So you choose by default to route on best stats, but also with limits on revenue, for example. So you can combine and then load balance between multiple carriers and all this stuff. Then also limit the channels which you send to specific suppliers. So the engine has to compute a lot of rules inside, and it's capable, it's perfectly capable of doing that. Fraud mitigation, you have access to multiple subsystems, so it's not anymore just the billing part or the bundles part. For example, if someone recharges too much money in short interval, you can also flag it as a fraud. Then if someone is hitting too high number of channels to a specific destination, it's again fraud. So statistics is again, so if he does more average call duration than normal, it can be fraud and so on. So you have so many places where you can detect fraud. It's not anymore just per destination. And you have also informative versus reactive, so we can react by shutting down, as I told you, the accounts. You have escalation procedures defined, and yeah, it's you have to complain if something is missing, but I have the feeling only AI integration is missing. Stat server, you have the difference of the stat server, since we have this advanced caching and in-memory database and stuff, we could build all the statistics in memory. So you don't have to press a button and wait like 15 minutes until your ASR for the last day shows up. Now it's real time, and you can react on that. So the CDR comes in, your stats are already updated. And then you can react. As soon as the ASR drops, you can already send notification out, and that is real time. Then you have a lot of strategies, most of them which they are used in telecom nowadays, and then you can also have generic statistics. So you can say, I want to calculate the sum of this column in my events, so you don't have to just go with all this ASR, ACD, PDD, and which are coming from the history. Then resource utilization control for virtual resource counters, and the one which I told you about, virtual channels. Mediation server, so you can enhance your events. An example of mediation is the emergency services, where you have to map the user the closest available emergency service center, or number portability, which you have to again replace his number to the real one, which he converts to. And or the kind of LCR and this LATA stuff which you have here, this can be done also with the mediation server. Then billing assurance, like parallel billing to what you have today already. This happens, there are projects which they have to testify existing billing, so compare always billing from two different sources. And recently, the most craziest thing I could think about adding in a billing system is IP address management. Everybody will say, what does IP address and DHCP have to do with billing? And then I will tell you that the new eSIM services in the mobile world, they need IP addressing. And people who are able to statically control the assignment of the IP addresses, they make a lot of money out of it, because by default it's all DHCP. So mobile networks, they offer by DHCP. If you are able to give static IP addressing to your mobile headsets, then you start building private VPNs between headsets of your big, large corporations, SCaLE or whatever, and then you enhance the value-added services for mobile world. So this is why we have IP address management in CG-RAIDs, because we are part of the mobile networks, and then we have to offer enhanced services there. This is some sort of architecture I tried to build. Maybe it's too little font size. The agents are the interfaces out. So diameter, radius, HTTP, DNS, I told you about SIP agent, and here is also the asterisk agent, so we can talk directly at the edge of the CG rates infrastructure, different dialects with different switches. We also have free switch, we have Kamailio, we have OpenSIPs, and then we have something which we call ERS, which is Event Reader Service, which is able to map and read various databases of information, various message buses, and CSVs and other supports for CDRs. And then out of these events, we push into a system which we call sessions, and from that moment, the single event, which I'll show you coming, for example, from Asterix, it becomes a session. So we can make sense of billing per repetitive, like in every few seconds. This is very useful because you can have concurrent accounts dialing in the same time, and then the old type of emulated prepaid doesn't work anymore. So you have to regularly charge concurrently from accounts. And then from sessions, then you have access to all our subsystems, what we call core subsystems, which is rating, CDRs, attributes for mediation, chargers for multiple charging, rates, and resources for virtual. I told you about routes, stats, thresholds. Trends is also interesting because it can build up trends, so you can compare the traffic of today with the traffic you had 24 hours before. Again, a way of doing fraud detection, because if the trend is not, like if you get a sudden increase of 10% or more, you want to be notified, because that's again something abnormal, or comparing to the best to the same day in the week, last week. And then you have also rankings, so you can, let's say, tell me my best 10 suppliers where I'm sending my calls and stuff like that. And then you export outside, and you can put it to our own database, or you can put to any kind of database outside of our system. Session processing, we have some states here which are important, because I told you we get events. So for example, from Asterix, we get events as well. So we have 5 different states in our system. So one will be session authorization, and that's before routing. So that's before dial plan, before the dial application in Asterix. And here we can return maximum session duration, we can do resource authorization, we can do session properties, adding session properties, for example, PayPal address if you want to keep it stored in the session, whatever. And also routing if you want. And then we get the session start, which marks us that we can start charging in real time if we want to. Session update is not used with Asterix. It's used, for example, in mobile world with diameter updates. And session terminate, which tells us the session was over, so we can stop all the processes of real-time charging. And then session CDR, which writes the CDR in the database or forwards it to the next place. Then, now coming to the hot topic, Asterix and CG rates. Asterix integration, it's actually done, it was done quite some time ago. So we have done it in 2016. So we were directly advised back then by Matthew Fredrickson, and we are not Asterix experts, so we just know how to restart Asterix and how to put things in the dial plan a bit, but that's all we know, unfortunately. However, this works, and it's used by people we know, and we can call them customers. So 16, ARI was pretty fresh. So it was AMI before, and we were advised, okay, if you're starting now, start with something which is new. So ARI was the thing. And back then, we could not find a good Golang library, so we had to write our own Golang library, which we call Aringo, which it's quite, it sounds like vacation time for me, for example, Mexico and Spanish, but it's just ARI in Go language. So it's maintained by us, so we can freely and fast fix its problems. Calls are not authorized if CG-rates is not operational, which again, it's the break before the engine, which I always appreciated. And we also are able to generate CDRs out of events with extra fields from stasis attributes, which we can feed in at the start of the call. I'll show you how. And we can also do asterisk integration purely CDR driven, so offline charging out of CSVs, for example, generated, I hope is still actual CDR CSV module. How we have done it, because there were tricks since we could not find everything what we needed back then, and I think it's actual. We needed to apply certain logic from asterisks and certain logic inside CG-rates to make them work. So this is why I'm sharing it. Maybe you are in the same position, you want today to implement a billing real time for yourself. This is what we have done to make it work. So when the when the call starts, we were not able to feed in via dial plan our extra information from CG-rates. So we had to send it to the module which we need. So we had to feed this via a stasis application. So when calling stasis from the dial plan, we are pushing extra variables which we need. For example, this is the CGR account, and this call should be prepaid or postpaid. So we'll send this via stasis. Then, once this is inside CG-rates, we cache this information, so we keep it like in parallel to what Asterisk has. Because when the CDR comes in the channel destroy message, we don't have all the account information and all the things which CG-rates has set, so we can retrieve this part from CG-rates. And it works. So also, there is a two-way data exchange, so we are able to feed in additional information. For example, when doing routing, we send with stasis start, we send the request inside CG-rates, and then it will stay there forever until we send it back, right? So from this point of view, it's secure. If it's not authorized, it will not go through. It doesn't go to the next dial plan extensions, but we can then also feed in the routing information. For example, we can specify the gateway where you should send the call, so gateway ID, and then you capture this information because we feed it in via post in channel variables nowadays with WebSocket. This was the change of bidirectional ARI. Before, we used to set a post to an HTTP server of Asterisk, which was part of ARI, but now we, on the same WebSocket, which is opened when the ARI comes up, we can feed in instructions to Asterisk. So we will set, or we will inject information like routing and other information from the CG-rates, or we have gone through like using CG-rates as a database if you want to. So we are feeding this information via two-way data exchange. when the call is disconnected from the CG rate side. So if we detect that the balance is finished, we will send a delete on ARI channels, a delete method, again over the WebSocket, and kill the call from CG rate side. So if fraud is detected or you shut down the account while the call is going through, we are able to detect that because we do every 5 seconds debits, and we will kill the call from the engine side by just injecting over the WebSocket a delete message. Then channel disconnect is not sent after returning to dial plan, and for that we use this subscription, so we will be kept updated about what's happening to our channel. So the channel, but only channels which we monitor for the billing side. So we subscribe to information regarding what happens to the channels, because otherwise we cannot do the billing also. And we will consider, remember we have channel start in CG rates when we need to start billing. So we will have channel state change received from ARI, and we need to have state up. So we know that the call started, and then we can start charging. And we will consider that the call terminates when ARI informs us with channel destroyed message. And in channel destroyed, we have CDR bill sec, and this is the total call duration which we use to bill for. So this, I don't know if it's, you are able to read it from there. Otherwise, I'll just share my slides and you use some glasses. I also start having the problem nowadays, so it's perfectly normal. On the left side, you see this is part of the authorization. So we get status start when the call starts, and then we will send a REST request to the asterisk to subscribe for news regarding this, which is confirmed by asterisk with REST response OK. Then we will send the REST requests to add channel variables, as many as we want to the channel. And in the end, we will send another REST request to say continue. So we release the call from status application. And from there, based on our subscription, we just monitor. We don't interfere anymore. So you can route it in any kind you want. We will just be notified that your call was started and then your call was ended. And of course, as I told you, we can also send delete instructions so we can kill the call. And this is the what we call accounting. So that's, we receive channel state change with the status up saying that the call started. And then we send later on, we can send REST request, delete the channel. We get the channel hang up request, and then we also get channel destroyed. All the other events, there will be a lot of other events, channel var set and whatever, dial plan events and stuff, we ignore. So we still get them because we have subscribed to them. We love to filter them out directly in Asterisk, not to be sent to us, but we don't know how. So, and I don't know if that's possible. However, we ignore all the other messages. And it looks like complicated, right? I told you so much information, but the good news is that this is all you have to do in CG rates to get Asterisk connected inside CG rates. Of course, configuring CG rates is another story. You enable an Asterisk agent, you set its address, user and password, how many times it should attempt to connect, and ARI WebSocket true. If you put it on false, we will still work with the old Asterisk version. So we work with both old and new way of doing ARI. And you can also select here to create the CDR, or you can still build the call out of CSVs. So you can do maybe routing with CGRates and billing out of CSVs. You can select here CDR false. And in asterisk, as I told you, we initialize one channel variable named CGR max session time, which we later use here in the dial application in order to set the maximum call limit. And this is like a security timer for your call. Even if CGRates loses connectivity for some reason, and it doesn't detect the fraud or whatever, your call is still limited to initial security timer, which is calculated when you start the call. So yeah, these are things which you have to do. So here is the stasis information. So you set some channel, some information which CGRates needs it. This is the exchange which I told you, enabling also some of the modules of CGRates. So you can select which functionality you want from CGRates by setting these variables. And then you have here in the hang-up handler what you do when the call hangs up. And I'll just end up here with 3 minutes before. So this was really roughly calculated by me. I just put slides and let me see. David, I hope you don't hear that. Let me see how much it goes.
I think we have a timer that you set for yourself just right. So to end presentation, if anyone has any questions for Dan Christian Bogos, happy to run the mic around. Oh, there we go. Mark.
Cool, thank you. So for the real-time part, you mentioned that there's security, like where it'll reject the calls, right? If the server CGRates is down and it can't process.
Yeah,
So,
actually, it's not rejecting, but it will stay forever in stasis.
okay, gotcha. So is there an in-between? Is there a hybrid where, let's just say, you have to take the server down or it crashes, and then you want to continue the real-time? If you start that back up, is the real-time now out of date? Can it catch up based on CDR and backfill?
No, because you have to be subscribed in order to get the channel updates. And if you are not subscribed when the call started, you have missed it. But you can also feed the CDRs from CSV, and then it will automatically process the ones which were not processed by CGRates. So you just dump everything what you have, and most of them will say duplicated because we detect duplication based on the channel ID, and then we reject it.
Right, okay. And then I had a part 2 of that real-time communication, which was with asterisk, right? Are you directly listening to like dial events and things like that? Like what about things that are asynchronous, like originate? People doing click-to-call, like would that still be able to run through like the engine?
Anything which you can send to stasis. So in your dial plan, you need to call stasis in order for CGRates to react.
Right.
Otherwise, we don't see them, and we don't take responsibility for it. So today we just do stasis start, I think it's called.
Yeah, so integrator would be responsible for their own like firing off CGRates when it's necessary.
Yeah, and you can do reload of your dial plan if you want to catch up and start sending.
Gotcha.
At some point.
Okay. Yeah, good.
Great question. Does anybody else have a question for Dan? Okay. Well, we're right at 2:30 on schedule. Thanks again, Dan.
Thank you very much. Thanks.
We'll take about a 15-minute break. Looks like we still have some coffee, but snacks may have disappeared, so unless they were gone, that was your chance. I see 1 or 2 bags of chips left there, some coffee and tea. We'll get back started at 2:45. Then we have a couple of talks and one remote presentation from Josh about performance improvement to wrap out the end of the day at 5 o'clock. So if you mosey on back in 15 minutes, we'll get started for the last couple hours. Thank you.
think so.
Okay, everybody, I think we're going to get started here in just a minute. You can find a seat. Still a little bit of coffee left. I think the snacks are gone. There's water too, so feel free to get another couple hours here of presentations till 5. Again, my name is Chris May, Open Source Solutions Advocate at Sangoma. Welcome back to AstriCon 2026. Happy to have you here. We've got a number of talks about FreePBX as well. Of course, one of the most popular open source GUIs for Asterisk. Been around for a number of years. You may have seen a few Tango the Frog mascots out front. Be sure to get your picture, just posed for some myself, with the SCaLE penguin and the Asterisk kit, the Asterisk mascot, and Tango the FreePBX mascot, all there to take your picture with, smiling happily. I am excited about this talk. I've spent quite a lot of years before working with Asterisk and some FreePBX, and a lot more time with FreePBX these days at Sangoma, and come to find out that Rajan Patel has worked on some FreePBX on Ubuntu while we've been working on FreePBX on Debian, showing what a great option it can be for a variety of different operating systems. So I'm very excited about this talk. If you can bring your attention over to infrastructure as code for rapid FreePBX deployments, hand over to you, Rajan.
Thank you, Chris. Can everyone hear me okay? All right, mic seems like it's good. So I'm Rajan Patel. I'm an Asterisk and FreePBX evangelist, and I love the project. I think more people should use it. And over the years, I've installed FreePBX and Asterisk a lot. My favorite place to install it is on Google Cloud because of the free E2 micro virtual machine that you can get with 2 shared vCPUs, 1 core, and 1 gigabyte of RAM. It costs $0 to run. And if you spin up a Debian image on an E2 micro instance and run the installation script, it will fail. But today, I will show you how to get it going. So in 2023, people were trying to launch virtual machines on Oracle Cloud to use the extremely generous free ARM tier to run FreePBX and Asterisk. And Oracle does not provide Debian images. So users opted for Ubuntu 2204 to install FreePBX and Asterisk, and there were some subtle differences between Debian and Ubuntu. And I knew where people would get stuck. So I authored some infrastructure as code deployment templates so people could launch FreePBX and Asterisk on Ubuntu, on any architecture, on any cloud, and it's guaranteed to work even on the smallest VM offering anywhere without any friction. So I've been maintaining these infrastructure as code templates since 2022. And the path that I see most people take when they want to install FreePBX and Asterisk, they launch their favorite OS, they SSH in, and then they follow the documentation to bang out a FreePBX and Asterisk installation. And then when they're done, they configure it and then think, I should bookmark this spot. Because if something goes sideways, I can come back to this moment and then pick up where I left off. So you take a disk snapshot. So disk snapshots are bulky. They're impossible to reconfigure without redeploying and taking new snapshots. And from a security patching standpoint, like a golden image is going to become stale the day you make it. So if you have a stale snapshot, you can take a new snapshot. It's not elegant, but it works. You still have the same problem. And now you have a growing catalog of snapshots. So this is a bad workflow, and I think it's rooted from the days of antiquity. If your FreePBX went offline due to a vulnerability, and you're using images or disk snapshots, you're relaunching a vulnerable system. That's awful. And what if you made 5 or 6 changes in FreePBX since your last snapshot was taken? Now you have to replay those changes on the newly launched, still vulnerable system. So that's double awful. And if you want to do this for many FreePBX installations, this can become a full-time maintenance job. So with infrastructure as code, your business can sell to enterprise customers already using this technology. So in the world of disaster recovery, speed is your best friend and ambiguity is your worst enemy. So what if you could declaratively configure the desired state of your OS and all the software installed on it in one place. And it would install and configure FreePBX and Asterisk on any future revision of your OS. So this solution is going to remove the guesswork from rebuilding FreePBX deployments. Now, these are some of the benefits you get with infrastructure as code, and if you're not an expert on this topic already, you will be in the next half hour. So if the idea of infrastructure as code scares you, remember that most of this is just JSON and YAML. It is both machine and human readable. Cloud Init takes an initial configuration that you supply in a YAML file, and it automatically applies those settings when the instance is created. It's rather like writing a to-do list, and then let Cloud Init deal with the list for you. You can even add conditional logic with variables, if-else statements, and loops, and then you can use Jinja templating to accomplish this. It is the industry standard for Linux instance initialization. It's used by every major cloud, every major virtualization platform, and it's a canonical-led product since 2007, with active participation from the likes of Red Hat, VMware, Microsoft, Amazon, and others. So this is my Hello World equivalent for a Cloud Init file. The ## template : Jinja header tells Cloud Init to treat this as a dynamic script rather than a static file. And that curly brace %set, that tag is a Jinja statement, and that creates a temporary variable during the rendering phase. So essentially, Cloud Init processes the logic first, strips out the Jinja code, and generates a clean, custom YAML file that's tailored for the specific instance before any configuration actually begins. So I like to set my variables first at the top of the Cloud Init file, and then I use those variables in the Cloud Init file later on. So this is like a fill-in-the-blanks template because your configurations would change from one FreePBX deployment to the next. And many people will store sensitive information in a vault. It's possible to retrieve secrets from your cloud or hypervisor's vault if you were inclined. I didn't want to add that complexity to this Cloud Init file here, but it is possible to do. So the first thing we'll configure is email. The server's cron tab can send email alerts. FreePBX needs to send voicemails and update notifications. So let's set the SMTP service provider credentials here, and then later we'll instruct Cloud Init to use them when installing and configuring postfix. Again, you could use Jinja to populate this variable with a secret from a vault, especially if you're versioning this file on GitHub. Now the host name and fully qualified domain name are needed to set networking and mail configurations. By setting the host name and FQDN as Jinja variables here, you ensure that services like postfix are configured appropriately, and you're preventing mail delivery failures caused by domain name mismatches. You can use conditional logic in Cloud Init. So here I'm using Booleans to define which trunks should be enabled or disabled in FreePBX, and where I should download my backup tarball. So this allows Cloud Init to skip entire blocks of configuration for disabled providers, ensuring only what you intend to use is installed and configured. This will work in conjunction with the FreePBX backup and restore module, and we'll get to that in a moment. So you're going to want to use fail to ban to block bad actors. So you can set IPs that require unrestricted access, like your management subnet and SIP endpoints. This ensures that fail to ban never blocks legitimate networks. If there was a human error and a device with the wrong username and password was deployed, retries are going to keep reoccurring, and then fail to ban could block a large number of devices if this allow list isn't added. Later, we'll also itemize SIP provider IPs and add them to our fail to ban configuration. It'd be a little silly if we blocked one of our carriers. Now, unless you need time to be tracked in UTC, it's a good idea to set your local time zone. Reading timestamps of scheduled tasks and call records, it makes more sense in your local time. Now consider when you want the maintenance window to occur. So for your automated security updates, the time specified here, it's going to be used to configure the unattended upgrades package and the needs restart packages. Optionally, you can disable unattended upgrades if you're using something like Landscape to manage your estate. Now, long-running FreePBX instances can use all the available disk space with comedic results. Everything goes offline. So this section defines the database cleanup policy for your CDR and CEL records. And by setting these Jinja variables, you're providing the parameters for a SQL command that will periodically run via cron. Consider your retention requirements and then adjust this accordingly. Now this is an Ubuntu-specific configuration. If you're using Debian, you don't need this. So I'll use this variable as a version control toggle for PHP, further down in the Cloud.init file. Now this is the end of our variable configurations. We're going to move on to the meat and potatoes of Cloud.init. So this is a list of tuples in Jinja. It's a type of dynamic data structure. The purpose of this is to map SIP trunk providers to their enabled or disabled status and their network ranges. So by grouping the provider name and its activation flag like enable flow route and its signaling IPs together, you enable Cloud.init to programmatically loop through this list, and then the script can automatically build firewall rules and SIP trunk configurations only for the providers that you've marked as true, keeping your security clean and automated. So the for loop on the next slide is going to use this list of tuples. So we're using Jinja logic to programmatically build a security whitelist. It starts with your user IPs, and then it loops through the providers list to append the signaling IPs only for the services that you previously marked as enabled. And finally, it's using a Jinja filter. If you notice that pipe join, that flattens the list into a single space-separated string, and this is perfectly tailored for the ignore list for fail to ban. So all the SIP providers that you're using and then the users that you've configured for your FreePBX install, they're all going to be prevented from being banned by fail to ban. Now this section uses Jinja string manipulation to dynamically extract a base domain from your fully qualified domain name by splitting the string at the dots and grabbing the last two segments. So for example, if you've got freepbx.subdomain.yourcompany.com, it can extract yourcompany.com. And it programmatically identifies your root domain. And finally, it's using Jinja expressions, the curly brace, and then the variable name that injects these processed values directly into the standard Cloud.init host name and FQDN directives, ensuring the OS identity is set correctly. Now, of course, you could skip these Jinja gymnastics and just write the host name and FQDN into those variables, but then you wouldn't have learned about this whole Jinja string manipulation thing. So I'm just showing this as an example of what could be done. You probably would have other use cases. Now, Cloud.init has modules, and these modules are run in a specified order during startup. So resist the urge to use the run command module, run CMD. That's where you can run arbitrary commands, and you can do everything. But the best practices are use the native modules as much as possible, and then use the run command section as sparingly as possible. So this is the users module in Cloud.init. It's used to create the service account for Asterisk, and by defining the Asterisk user with passwordless pseudo privileges and setting lock_password to true, you're ensuring the service has administrative permissions that it needs while strictly enforcing SSH key-only access for better hardening. Now the Cloud.init write files module can write files anywhere on Linux. I'm using it to create a systemd override for the apt daily upgrade timer and to set a security patching schedule of my choosing. By injecting the security install time Jinja variable directly into the on-calendar field, it forces automatic upgrades to run exactly when you specified in the variables earlier. This effectively replaces the default random schedule with a predictable maintenance window, ensuring that your PBX doesn't start updating during high call volume hours. This is a continuation of the write files module. Here we're writing the postfix credentials file, and by mapping your previously defined SMTP variables directly into the SASL format, or SASL, however you're supposed to say that, Cloud.init creates a sensitive configuration file with restrictive 0400 permissions, which is read-only for the root. And this ensures that your mail relay can securely authenticate with providers like SendGrid or Gmail if you're running like a super free version of this thing. Now we also write a systemd service unit to manage the FreePBX lifecycle. This is quite standard as far as systemd goes. I can come back to this slide if you guys have questions. But by defining the after equals mariadb.service dependency, it ensures that FreePBX only attempts to start once the database is ready, using the FW console command to cleanly initialize or stop the PBX services during system boots and shutdowns. Now this is still in the Cloud Init write files module. This is an Ubuntu-specific step and not necessary on Debian, but by creating the /etc/odbc-inst.ini file here, you're building the bridge that allows Asterisk to communicate with MariaDB. So here we're using Cloud Init write files to set a custom log rotate configuration, preventing Asterisk and FreePBX logs from consuming all the available disk space. I've encountered that pleasantry as well. I've had FreePBX installations go sideways because the logs chewed up the entire disk. So follow your retention policies and be mindful to use a post-rotate script for Asterisk to reload its logger. This is going to ensure that Asterisk seamlessly switches to new log files without needing a service restart. Now, fail-to-ban jails are defined through configuration files. So here we've created jails and set an allow list of IPs to ignore from our fancy loop earlier and specified where email notifications should go. Now, I don't want email notifications for SSHD. I'd get emails constantly. But I am curious to get email notifications about brute force attacks on FreePBX and Asterisk. I'm looking at the Asterisk security log and the FreePBX security log for 3 failed attempts within 2 minutes before I block IPs automatically for an hour. Now the parentheses action underscore MW macro, that ensures that whenever a block occurs, an email notification is sent to the address that we defined earlier in our Jinja variables. Now fail to ban will fall over and cry if the log files for Asterisk and FreePBX don't exist. So the Cloud Init write files module to the rescue, we create empty log files with the appropriate permissions. And while fail-to-ban can understand Asterisk logs, we need to teach fail-to-ban how to read FreePBX logs. So we write a filter file with a custom regex pattern that fail-to-ban uses on the FreePBX log file. Now, if you're reverse engineering the regex, you know that we're looking for the string authentication failure and extracting the host, which is the IP address, so it can be passed to the firewall for blocking. Now, by using Jinja conditionals and variables, we write a cron tab ready file that manages 3 critical areas. We've got recording cleanup, voicemail rotation, and database optimization. So for recording cleanup, it's going to delete the directory structures for call recordings older than 1 year, and it's going to prune all the empty or tiny ghost audio files. I have no idea what they are, but I see them in there. Then there's voicemail rotation. So let's automatically remove all old voicemail messages after 45 days to save storage, but again, follow your retention policies. And then database optimization. So this uses the CDR retention days and the CEL retention days variables that we set earlier to purge old call logs and optimize the MariaDB tables. So this is going to reclaim disk space and keep the database queries fast. And later on, using the Cloud Init run command module, this schedule.txt file that we have written, it's going to be installed into the appropriate cron tab. Now the apt module in Cloud Init can set apt configurations on your server. And here I'm configuring unattended upgrades with the apt : periodic settings. So these ensure that the OS automatically checks for updates and downloads security patches and cleans up the package cache every 7 days. I can also configure repositories with conditional logic. Am I happy with PHP 8.3? Or do I want PHP 8.2? Now this is an Ubuntu concern. It's not something that you have to worry about on Debian. I'm using Ubuntu, and I want Canonical to security maintain my PHP, so I'll install 8.3 from Ubuntu's repository. But if you want the same version that is on Debian, you can install 8.2 from this Debian maintainer's PPA. So using a Jinja if block, it adds the PPA repository only if you specifically chose PHP version 8.2. These are pretty easy. Package update. So that refreshes the local package index to ensure you're pulling the latest versions of the software. It's the equivalent of running apt update. Package upgrade. That upgrades all the installed packages to the latest available versions. It's the equivalent of running apt upgrade. And package reboot if required. So this detects if there's a kernel update or a critical library change that requires a restart. And if so, Cloud Init will automatically reboot the instance and then resume where it left off to perform the remaining configurations. Now this section uses conditional Jinja logic to optionally add the Ubuntu Pro token to your server. This is, of course, only relevant for Ubuntu users. If you're using Debian and you know how if statements work, you can close your eyes. But if you provide a token, Cloud Init automatically attaches the machine to your canonical account and enables 3 enterprise-grade security features. First is Live Patch, which is going to apply critical kernel patches in real time without requiring a system reboot. This is vital for kernel security between your normally scheduled security maintenance windows. The next is ESM Infra, which extends the life of your Ubuntu LTS beyond 5 years. We security maintain Ubuntu LTS for 15 years now. And ESM Apps, which expands security patching to include all the open source applications in the Ubuntu universe, including Asterisk and all its dependencies. So if you're deploying this to an environment that conforms to the US government hardening frameworks, then you can add FIPS updates to this list here as well, and that's how you're going to have a government-ready, hardened Ubuntu installation with Asterisk and FreePBX on it. Now, using Jinja conditionals, we can validate the time zone variable before applying it to the system. Here we're just checking if a / exists, such as in America/New York or Europe/London. That if condition ensures the value follows the IANA time zone format. And this is the Cloud Init Packages module. It's a slimmed down list of everything required to run Asterisk and FreePBX. So Cloud Init automatically handles the installation of these packages and their dependencies. But it's worth noting that I'm installing Asterisk as a deb package provided by the OS. It won't be the latest version, but on Ubuntu it's the version that is security maintained by Canonical. Now this is a continuation of that list of packages that will be installed. We're using Jinja variable interpolation to dynamically install the PHP environment specified in the PHP version variable. The PHP extensions will only work for their corresponding PHP runtime. The version numbers must align for both. A PHP 8.2 extension won't work for PHP 8.3. Now we're at the run command module, everybody's favorite. It's executed last. Now, I use run command to do a variety of things, starting with fail to ban configurations. So first I use curl to reach out to Amazon's check IP service and determine the public IPv4 address of the server, and tell fail to ban to never block itself. Now these commands are for Ubuntu only. In public cloud environments like AWS, Azure, or GCP, where Ubuntu Pro might already be pre-activated or attached at the image level, people won't be providing tokens in the Cloud Init file. We still want live patch and expanded security maintenance to be enabled, so these commands ensure that those entitlements are turned on. Now by default, Ubuntu will never reboot itself after applying a security update. It waits for human interaction. Now I specified a time that I would find this reboot to be acceptable, so I'm making these changes to the default behavior of needs restart. It's a config change, and then restart the needs restart service. That's a bit of a mouthful. Now these changes to unattended upgrades reflect my personal preferences. I want to set it and forget it. The system should update itself, but at a predictable time, and old unused kernels shouldn't be stored in perpetuity because my /boot doesn't have unlimited space. I also enable automatic reboots, and I use the security reboot time Jinja variable to schedule those restarts at my specified time. Now this iptables command performs a flush and save of the current Linux firewall rules. When I say flush, removes everything, and then we save it. So it first checks if any active chains exist, and if they do, iptables-f clears them, and netfilter persist save ensures that the reset survives a reboot. Now while this is specifically targeted at Oracle Cloud, which is known for deploying a highly restrictive default rule that blocks all traffic, this clean slate approach is a safeguard for any custom or vendor-specific image that might include pre-configured iptables blocks. I think the firewall rules probably belong, where the public cloud is allowing you to configure them, not inside the VM itself, but it's going to be external. Now this is a silver bullet configuration for tiny virtual machines on public cloud. You don't get swap space by default, and 1 GB of RAM is very small. But configuring a 2 GB swap file provides a memory safety net for FreePBX. And by using fallocate, mkswap, and swapon, the script is going to create virtual RAM disks and then prevent the Asterisk or MariaDB services from crashing when the physical memory becomes momentarily exhausted. The final grep and sed commands ensure this configuration is persistent, automatically re-enabling the swap space every time the server reboots. Now this block of commands configures postfix and then deletes the plain text SASL password file for security. Now postfix is restarted at the end to apply the changes, and your server can now send emails. So if you're enabling FIPS to run FreePBX and Asterisk in an environment regulated by the US government, Ubuntu is probably your only sensible path forward. You need to have a FIPS kernel, you need to have FIPS-enabled Node.js, you have to have all the correct cryptographic library versions, and a number of other tweaks that can be applied by just adding 3 lines to this CloudInit YAML file. But I'm happy to answer more questions about that if there is interest. Now, by recursively changing the ownership across the /etc, the /varlib, the /varlog, and the /varspool directories to the asterisk user and group, it ensures the asterisk service has the permissions needed to manage configuration files, store voicemails, and write logs. The sed commands then modify the system defaults and the core asterisk configuration file to explicitly instruct the processes to run as a non-privileged user rather than root. So this hardens the system against exploits. Now this is some symlink magic only relevant for Ubuntu if you're on Debian. Don't worry about this. And more PHP version shenanigans. You can ignore this if you're on Debian, but I do recommend the changes to php.ini. This increases the upload limit in memory. This section also configures Apache to run as the asterisk user and enables mod rewrite and clears the default index page to make way for FreePBX. Now it's time to download and install FreePBX. There's a race condition between asterisk start and the FreePBX install instructions. So waiting for the core show version to produce a valid response guarantees that your installation doesn't fail. On Ubuntu, you must perform a database path correction within the odbc.ini configuration, remapping the socket path from the default var lib mysql.sock is necessary because Ubuntu uses run mysqld.sock. Small change, but without it, it's not going to work. Now, these are some modules I've tested and used on Ubuntu. You can install Sangoma's commercial modules this exact same way. There may be a few additional licensing steps, but I'll defer to them in the Q&A about that. This command creates the necessary symlink to ensure that FreePBX starts automatically every time the server boots. Using crontab, we can mount the jobs we previously wrote to schedule.txt. And you can use conditional logic to decide which backup file is going to be used for your FreePBX deployment. You can use your baseline configuration, or perhaps you have a point-in-time backup that you're trying to restore. And restoring from a backup is easy. FW console backup -- restore, and then the path to your backup file. Now, if you're anal about keeping things clean, you can run MySQL commands using FW console. So I use it to remove trunks that I may have restored from my backup, but I don't plan on using. Again, purely optional. I think it's important to apply this T38 fax over IP setting in the database, which sets the error correction to redundancy. This is essential for reliable and accurate faxing, and in my view, should be the default setting. The subsequent FW console commands serve as the cleanup crew. Chown fixes any remaining file permission issues. Reload generates the final configuration files from the database and tells Asterisk to read them. And restart performs a full service bounce to ensure all modules, including the freshly configured SIP settings, are running in a clean state. So what now? I want you all to try this yourself and see how easy it is. It costs you nothing. Search for FreePBX Ubuntu on Google, and you will find this GitHub repo. Or you will find my article where I talk about faxing and ECC with Asterisk and FreePBX. Now, the GitHub repo is linked from the article. Now, if you're kicking the tires with CloudInit on Ubuntu, please use Ubuntu Pro. Personal users get free tokens, and businesses kicking the tires can use these free tokens for evaluation purposes. Just don't spin up insecure software. On the current Ubuntu LTS, so 24.04, Canonical has published security updates for the following Asterisk and FreePBX dependencies. They're only installable if you have an Ubuntu Pro token attached to your machine. And I'm busting the misconception that Ubuntu Pro is only necessary after the 5 years of standard support. It's relevant on day one of the Ubuntu LTS release, because if you're installing any open source package from Universe, you want to get the security maintained versions of those packages that are available to Ubuntu Pro users. So now you're all Cloud Init experts. Thank you. And if you guys have questions, I'll take them. All right. Thanks very much, Chris.
Yep, we've got some over here. Thanks, Rajan. Great presentation. Come over here.
Thank you very much. Have you looked at deploying on any of the BSDs, like FreeBSD or Open?
I personally have not, but I'm sure if you were motivated enough to, you could figure out the corner cases and get it going.
Awesome, yeah, that'd be fun. Let's see, yep, right here.
Have you made a container image from anything that you built this way?
I haven't built an OCI container.
Docker.
Oh, a Docker container? Yeah, no, I haven't built any containers with this, but you could. There's nothing stopping you from creating a Cloud Init template, spinning something up, and creating a container from the results. If you're using LexD, then you can use Cloud Init to spin up LexD system containers. If you're using multipass just to kick the tires on Ubuntu, on any OS, Mac OS, Windows, or any other Linux, then multipass will also let you launch VMs with a Cloud Init YAML file. So wherever you're spinning up a virtual machine, and it doesn't have to be Ubuntu, you can supply a Cloud Init YAML configuration file, and it will be the thing that defines how that Linux is going to look once it's launched.
We included some Cloud Init in our FOG ISO for FreePBX, so it's a little friendlier now. We'll talk about that after, I guess. But any other questions for Jean about installing FreePBX on Ubuntu? Debian's favorite cousin, maybe, I suppose, yeah. All right. Thanks so much.
All right. Thank you all.
So I think we're going to have just a few minutes here before David's talk begins, and let him get situated, and also take a look at some contrast on our small screen. If you'd like to see closer, feel free to mosey on up.
Avoided making any serious money by geeking out over Asterisk and playing around with it. I think we're in the same position with vCons. We can get excited about creating them, but actually the real money will be made in the way that vCons are used, because they can provide a memory of conversations. Now, if you're worried about the way that vCons will be used in terms of data protection, authorization, signing, and all that kind of stuff, there's a parallel standard called SCIT. And SCIT stands for Supply Chain Integrity, Transparency, and Trust. And all of that is on the IETF as well. So I'll give you another link at the end about that. So these are kind of parallel things that the IETF is dealing with. And when I say the IETF, one of the prime movers is a guy called Thomas McCarthy Howe, who's actually started a company called vConic recently about this. Now, these AI tools, so these are tools that could be using vCons. What could they do? Well, obviously the world's your oyster. However, here's a few examples. Customer service insights, understanding the way customer service journeys work, optimizing them, making it better for the customers. Behavioral predictors, like when people are most likely to buy in a sales cycle. Sales growth and acceleration, customer delight and retention. BPO, everybody loves a bit of that. And identifying new product and service opportunities as well. Really, the possibilities are totally limitless once you've got all of this data into the right place to be able to analyze it and work with it. And then you can point your AI tool in any direction that you would care to. Now, how can we how can we create vCons in the world of Asterisk? Well, you can do it entirely from within the dial plan. That's what I'm going to show you, because that's what I experimented with first, just to make sure I could do it. However, in production, you probably wouldn't want to do that, because there's a few moving parts that could actually, if there was some poor connectivity or something like that, that could slow up your call processing. You don't want to do that. You're much better off calling a script and then moving on. And that's the next version, is calling a script. And then the last way is going to be looking at the carrier doing it for you. So now this is when we actually jump into the dial plan, and forgive my total lack of use of different colors here to highlight different things in the dial plan. But first of all, we're setting some global variables. And as you know, global variables can be used anywhere, in any channel, at any part of the dial plan. And we're just setting up a directory for where our vCons are going to be stored and for where our call recordings that are associated with those vCons are going to be stored. By the way, if at any time something comes up on the screen that you want to talk about or you want to ask questions about, just raise your hand and we'll talk about it. I'm all for just-in-time questions and stuff like that. Okay, then we've got our demo extension. As you can see, it's a very basic dial plan here. I'm calling a no-op just to tell everybody what I'm doing. And then I'm setting a variable called vCon start epoch and basing it on the Linux epoch that Asterisk has pulled through there. Who can tell me what that double underscore at the beginning of the variable means? Yes, Alexandra. Yes, I like what you're saying. The description I use is infinitely inheritable. You know, 1 underscore means it's going to be inheritable to the next channel. 2 underscores at the beginning means it's infinitely inheritable. It doesn't matter how often you change channels, it's going to be there. Okay, so we're setting up an infinitely inheritable variable. Then we're setting a particular parameter of a function called channel, and it's the hang-up handler push parameter, and that's actually wanting the direction of a go sub to go to. So what we're saying is the subroutine we're going to go to is in a context called lab vcon HH for hang-up handler, extension S priority 1. Then we're just using the system application to call on Linux to make a couple of directories there, as you can see, the vcon directory and the vcon record directory, and we just set those previously, didn't we, in the global variables. Everybody with me so far? Good. Okay, love it. All right. Then we're setting some more infinitely inheritable variables for the name of the linked ID and the actual recording there as well. And you can see that we're using Mix Monitor, good old Mix Monitor. Everybody loves a little bit of Mix Monitor. And for an extra chocolate, what does the B option mean in Mix Monitor? Go on, Mark. Only record when it's bridged, so we don't get any rubbish in the recording. Did anybody else know that? Of course you did. You did know it, didn't you, really? You really did know. You all knew it, really. Oh, sorry. Don't want to hurt anybody here. Okay, so that's making the recording. Then we're answering the call. Then we're waiting for 5 seconds. Then we're hanging up. So all pretty basic stuff. So now let's get to the hang-up handler. And you can see then that we're setting the end of the end epoch and able to get the duration as well by having one minus the other there. And then we've got dealing with the timestamps, and we're setting the linked ID and the UUID. And then this is where the meat is. So this is all still within the dial plan. You might think this is a bit of a waste of a dial plan, really. But what we're doing here is we are very carefully using printf to create a complete file. So, do you remember this one? Hold on, let's have a little look at it. It was that. That's what we're creating here, isn't it? We're creating the JSON from within our dial plan. So let's go back to where we were. Yes, so you can see there, standard notation, the backslash for new line and all that kind of stuff. We're creating the entire vCon there, and at the end of it, we're putting it all in a file. Can you see the penultimate line there? We're putting it all in a file just called temp, $TMP in there, and then we're using the move to move it across into the right directory under the right ID as a .json file. Just while we're here, and since we are at SCaLE, which is a Linux place, what's the difference between a move and a copy in the world of Linux? You've already answered the question, Mark. I can see you're primed there on the edge of your seat. Go ahead. Yes, exactly. For practical purposes, a move is not going to announce it to the file system until it's all there, isn't it? Where a copy, you could accidentally get a half-baked thing if you're not careful. Good. Okay, thank you. So, then we're coming towards the end of the example. We've just got a little no-op. And then, look, we've got a return, because remember, it was a go sub, wasn't it? We were calling a go sub as the hang-up handler, and so that is the return of it there. Now, I've just shown you what not to do. The reason I've shown you that is just so you can prove to yourself, and that's what I wanted to do first, just have a little hack about to actually prove I could create a vCon that looked in the right format and had the right information in the right places to be able to pass out to anybody appropriate. And it works. Works great. Asterisk will create the vCon for you. However, in production, really what you're going to do is call a script. And the many advantages of calling a script include, number one, it's a very neat thing to do, isn't it? You're just going to call it. Could be calling it with an AGI or a fast AGI, however you want to do that. It's non-blocking in terms of the call traffic, and of course you get to use a language of your choice. I did it in shell script. Better people than me would have done it in Python or PHP or something like that. And you want two scripts, really. You want the script to actually create the vCon, as we've seen, and then you want a script to sign it for authentication purposes, because you don't just want any person or anybody being able to get into a vCon. Because once that vCon is created, it's immutable. You can't edit a vCon. Once it's created, it's there. What you can do is add to it afterwards, and it's like an appendage, if you like, to the vCon. But what you can't do is change a vCon. So that's the scripting way, and the scripting way, I would suggest, is the precise way you would like to do it in production. Now, I could have included an example to do that here, but it would have been, a long script and been difficult to show here. Suffice to say that if you'd like to see a script, I've got one from my experimentation. I'll be very happy to share it with you, and you're welcome to ask me afterwards. However, as I'm sure all of you have probably already guessed, and maybe even experimented with, AI knows all about vCons. Now, I wouldn't call myself a power user, but I can tell you that in my extensive work with ChatGPT, it knows all about vCons. So when I say, write me a script to create a vCon, it can do it pretty well. And if it doesn't, and you probably had this experience yourself, if it doesn't work, you can go, it don't work. And it goes, all right, let's fault find it together. Let's troubleshoot it together. So, it's a pretty straightforward thing to do. Now, the alternative to having Asterisk create your vCons is to use a carrier that can create vCons for you. Well, number one, it saves you the work of actually doing it, doesn't it? If the carrier is going to create a vCon for you, whoever you're using for your SIP trunk provision, and it gives you access to other things that might not be available at the time when Asterisk would have wanted to create the vCon. And those things could be a full transcription of the call. That might not be immediately available. It could also be an AI-based sentiment analysis of the call. There could be some keyword spotting. There could be all sorts of different things going on there. Compliance scoring for contact centers. By the way, isn't it interesting that contact centers, what they're going to look like in the world of AI, agentic AI? We never hear the old, all of our representatives are busy at the moment. You never need to hear that again. And of course, it turns out that actually the main problems with contact centers are people. Training the people, managing the people, making sure the people don't take too long for lunch or go for smoke breaks when they're not meant to. All of the problems associated with contact centers pretty much are people. If you've got an agentic AI, there's going to be consistency. I'm not saying that it should be doing people out of a job. It should be allowing them to then work on maybe the edge cases, or as I've noticed, it's very popular here to say corner cases. Let's say both. They can work on the edge cases and the corner cases. And if you insist on using Asterisk to do it, and as I said, not ideal for production, but if you did, then you can have Asterisk create the vCon, and then you can append things to it afterwards. And you can see the proper name for it is additional artifacts. So you've got a vCon of the basic information that Asterisk created, or that the script created at the time, and then you can add things to it afterwards. You can append artifacts to it, additional artifacts. Now, the other thing about a carrier is, of course, when we all started, the carriers were SIP carriers, weren't they? They did SIP stuff. Or maybe they did H323 stuff back in the day. Do you remember that? In the early 2000s, a bit like VHS and Betamax, weren't entirely sure whether it's going to be H323 or SIP. Personally, this is how much of a geek I am, I've still got a couple of H323 gateways, and I've still got 00H323 running in my Asterisk. And I just like to faff about with H323 gateways every now and again, just for fun. However, these days, your carrier is perhaps not only going to support SIP, maybe they support WhatsApp integration as well. So now you've got vCons from WhatsApp conversations with AIs, or WhatsApp conversations with person to person. Maybe it's text messaging. Maybe it's a WhatsApp call that you've got a vCon for as well. So if you're using a carrier that supports WhatsApp integration, now you've got a vCon for the SIP-based calling part. You've got a vCon for the WhatsApp part. Maybe you've got it for Teams as well if your carrier supports Teams integrations. Maybe you've got it for Zoom. In other words, you can have a multiplicity of channels, have all the vCon information, and with the right AI tools, well, you can see everything, can't you? You can see everything, not only from this bunch of conversations, but from that bunch of conversations. You can probably root out the entire history from when a person first made contact to when they bought the automobile, or whatever it might be. And of course, at the carrier level, then generally speaking, if a carrier is going to create your vCons for you, they can probably allow other people access to them that are authorized. In fact, I'd go so far as to say that when a carrier creates a vCon, they probably don't want to be responsible for storing it. They probably want to send it to where you want it and leave it for that, because of course there's implications if they are the conserver for this information. So using your carrier to generate vCons is also a great thing as well. Now, I've got a summary here, but before I get to the summary, has anybody got any questions they'd like to ask about vCons? Go ahead, sir. Young Chris will run a microphone to you.
Here. Yeah, I guess one thing I'm confused about is if it's going to be signed at the time that it's created, and in the future you might want to change who has access to it or take away access.
Yes, absolutely.
And in which case, do you attach another piece to it? Is that, and then sign that?
I don't know, sir.
Fair.
I'm old enough to be honest and say I believe that within SCIT, the supply chain integrity, transparency and trust, there's probably a mechanism for do that. You've got to be able to withdraw your right to be part of it as a person, as well as you said, all the other changes. And I do know that there's mechanisms in there, and I don't understand what mechanisms are, but they're definitely there, and that's one of the different things that before, you've got all these diverse things, and you don't really know what you're doing. This is going to be a universal standard that allows everybody to do it. So the mechanism is there, I just can't tell you how. Okay.
Great question. Yeah. Anyone else for a question on vCons? Yep.
Is there a minimum version of Asterisk that you need to be using?
No, not to do the experiment that I showed you, because that's just very, very basic dial plan stuff there. So whether you're running, I wouldn't suggest 1.2 or 1.6, but if you're on Asterisk 20 or thereabouts, yeah, you'll be close enough.
Good question.
There's one from Mark there. It's going to be a difficult one from Mark.
What major carriers are currently using vCons that you know of? Because you mentioned Zoom and Teams, but are they actually using this yet?
Okay, yeah, again, I will tell you the things I know. Simwood themselves have vCons in development. It's a Q1 2026 production goal, and they're on it right now. Sansei, the people that do session border controllers, are actually building vCon production into the silicon, or the silicone, I should say, of their equipment. But more than that, I can't tell you. But I'm going to point you to somewhere in a minute, Mark, and when it comes up, I'll go, Mark, this is for you, where you can find that stuff out. How does that sound? Good, okay.
Excellent.
Any other questions before we move on? Got a few more things to go over here. All right. Okay, in that case, let's jump into the summary. So, vCons are going to be incredibly important at this intersection of real-time communications and AI. And right now, we're at the very start of this. So imagine, go back 20-odd years, maybe more than 20 years, and you're hearing about SIP for the first time. We're in that kind of space. And Jeff Pulver, who I mentioned, is very excited about vCons. If you follow him on LinkedIn and places like that, it's pretty much all he's talking about. And he believes, he's quoted as saying, he believes that vCons will be as important, if not more so, for the telecoms industry than SIP was way back when. So, you know, he's setting a lot of store by this. Asterisk can create those simple vCons that I showed you from within the dial plan. Feel free to have a play around, but it's probably not the best thing for production use. The best practice is to have Asterisk call a script or scripts to create your vCons and sign them properly. But I believe the real money will be made by those that do work with the vCons. But what that means for us, I mean, maybe you can create something that works with the vCons, but what this means is, just like you might be able to charge for call recordings, transcription, sentiment analysis, you can charge for vCon production because they will be a very valuable source of data to the next layer up, if you like. Okay, further sources of information. And right now, Mark, this is for you. Look at the one at the very bottom. It says, follow Jeff Pulver, the vCon Foundation. The vCon Foundation has only recently been created, but there are a number of industry players that have already joined up. And I'll tell you the ones that I can remember. Grandstream, the phone and network gear manufacturer, are a founding or a charter member of the vCon Foundation. Sansei, that I just mentioned, I've run out of memory now. There's about 15 or 20 that are chartering members. And so if you go to the vCon Foundation and have a look, that will give you an idea as to the industry players that are already taking this very seriously. Is that okay? Good. All right, so other sources of further information. If you want to learn about vCon specifically, then in addition to Conserver.io, there's the IETF place that you can go to. The same for SCIT. All of the generative AIs know all about vCons. Personally, I've only used ChatGPT, but it did a very good job in not only creating scripts for vCons, but analyzing them as well. And then, as I said, Jeff Pulver and the vCon Foundation, very much worth following. Now, I've got another thing that I'd like to talk to you about. There's a little QR code there if you'd like to know more about Simwood Carrier. We support WhatsApp integration, we support agentic AI, conversational AI inside the Carrier network as well. And in fact, if you'd like to see it, I've even got a demo where I can be messaging over WhatsApp to an AI agent. And when I say I want to speak to a doctor in this particular scenario, it goes, all right, press the voice call button in this chat, and it routes, the Simwood network routes that call through to a Teams endpoint where my doctor is hanging out. So I've got the WhatsApp messaging going one way and the WhatsApp voice calls going the other way, all without ever touching the PSTN. So that's quite exciting. Anyway, there's a QR code if you'd like. The other thing I wanted to mention to you is, of course, we're here in the context of SCaLE, the wider Linux event. And I'm very excited to be able to be participating by delivering another talk on Sunday morning on the Open Source Careers Day. So if you're a technical person that would like to further polish your ability to interact with non-technical people, because, you know, geek to geek, geek to geek always works, doesn't it? But when you get geek to non-geek, especially when the non-geeks are handling the money, they've got the purse strings, sometimes our communications don't always make the trip. And so I'm doing a workshop on Sunday morning. It's called Human-to-Human Connectivity. It's all about the bandwidth. And so I'll be talking about 7 different bandwidth boosters between geeks and non-geeks. So the wider you can get that bandwidth, the more of your information can get across to them, and the more information you can see coming back from those people, whether it's buying signs or whether it's skepticism or whatever it is. It's all based on a book I wrote called Be the Nerd That's Heard. Because one of the things that I saw in the Asterisk community is I saw so many really great people who knew exactly what they were talking about. They really knew their stuff. But I just want to say this in closing, that knowing your stuff is not enough. It's the ability to present the right part of your stuff, not all of it. Because sometimes, you know what it's like when you get an electrician round, you ask for a quote, and he says, well, what I've got to do? I've got to do this. You don't really want to know everything he's got to do. You just want a price, don't you? And sometimes, as geeks, we're very tempted to unload everything we know about something. But if you really want to communicate with full bandwidth to non-technical people, you need to find the relevant thing in what you know, and to then communicate that in a way that can be easily received, digested, implemented, and actioned by those non-technical people. And that's what that workshop's all about. So, it's been a pleasure talking to you about vCons. It's been a pleasure going over some overview detail. We didn't go too deep into it, but I want the pleasure to come for you when you implement vCons and add another revenue stream to what you're already doing. Thank you very much.
Thanks, David. It was a great talk. I do love vCons and all that dial plan. Whew. Last talk is a pre-recorded talk, but will be live Q&A. So it is from lead engineer of Asterisk, Josh Culp, who we had some Q&A with this morning during the opening panel. He is, it's getting pretty late for him, so we'll try to move this along. And Mike Burdine is going to connect and get the Q&A situated as well. So it's a little bit of talk about some performance improvements in Asterisk, which has been quite a focus recently. We've been really polishing things up. Pretty excited to see you've got some improvements for CDRs, seems relevant. Got some improvements for AI, of course. Back in the day it was speech to text, now it's AI. Text to speech, now it's AI. Speech to speech, that's definitely an AI thing, right? So unless we're just been talking to people, but so we've had some areas that identified some bottlenecks and had some hunches, and there's been some experiments and some profiling that's really gone down and significantly improved things. So I'm going to give a few minutes here. We'll get started about 5 minutes with the last talk of the day. So if you need one quick moment more to stretch your legs, please do this now, and see you back here in quarter after. So 4 minutes.
Hi, everyone. Welcome to my talk.
Check, check, check. 1, 2, 1, 2. Yep. Good.
Hello? Not that I could hear any of you.
Check.
Josh, if you
Check
do
1, 2.
talk, they will hear you over the presentation, so you might want to mute until the video's over.
Yeah, we'll do.
Check, check. 1, 2, 1, 2. Okay, I think we're going to get started. Can you hear me? Is that coming through?
I mean, who are you talking to, me or
Okay.
or the room?
Check, check. I'm too loud. Was I too loud? You can't hear me? Very quiet. Too quiet? Check, check. It's all right. Needs a little louder. Ah, there we are. Are we ready? Yeah. All right, howdy y'all. Going to get started here in a minute. Back up again. Is that better on the AV? We're good? Cool, cool. All right, thanks everybody. It's our last presentation of day one of AstriCon 2026 at SCaLE 23X. Thank you again for coming for the day. Appreciate it. We have this talk from Josh pre-recorded. Mike's gonna steer. And it's about 39 minutes, and then we'll have some time live with Q&A with Josh. He's the head of the engineering of the Asterisk project. Mike is a senior engineer with the Asterisk core project. Ben, also in the audience, another core engineer on Asterisk. So, feel free to chat them up about other specifics that maybe Josh doesn't have time to answer because it is getting late there. So we will get started and watch this brief presentation on Asterisk, a deep dive into performance improvements in Asterisk.
Hi everyone, welcome to my talk, Under the Hood, Deep Dive into Asterisk Performance. My name is Joshua Culp, also known as the Asterisk Guy, the Hat Guy, a Director of Engineering at Sangoma, the Asterisk Project Lead, an open source guy at Sangoma. I have many different titles and things I do. But in the end, when it comes to Asterisk, I'm the person figuring out the direction of it, the roadmap within Sangoma for it, and also making policy and decisions about it. I wish I could be there with you guys in person, but circumstances did not allow it, so I hope this recording of a past version of me is sufficient to shed some light on performance when it comes to Asterisk. So let's go over what we're going to talk about. I'm going to ask the question, what is performance? Talk about the costs of execution when it comes to Asterisk. What makes calls expensive? We're going to dive into some of the more commonly used things in Asterisk when it comes to areas that can have performance impact, such as dial plan, AGI, PJSIP, AMI, ARI, and a bit more. I'm going to talk about some things to monitor, as well as configuration strategies, implementation strategies, and then we're going to try for a Q&A. So I want to throw out the question, although because I'm recording this in the past, I cannot see into the future. What is performance? That animation probably brought to you by Chris May, because he loves throwing animations into different presentations and stuff. But fundamentally, the definition kind of differs between people. You have at a system level, which is really easy to think about. So that's how much CPU is being used, how much memory is being used, how often storage is used, that's reading and writing and IOPS. As well, not on here is network. VoIP itself is actually generally lots of small packets which have an impact on network interfaces, particularly when you're in a virtualized environment. So from a system level, there's a lot of aspects, but for this presentation, I'm not going to really go into too much about system level. I'm going to focus on the asterisk side of things, also known as the application level. So from an application level, you can think about performance as calls per second, delays in call handling, that can be post-dial delay, concurrent calls, concurrent conference bridges, concurrent transcoded calls, queues, so maximum number of queue callers and agents in a queue, because queues are extremely expensive in a way. AMI message throughput. AMI is very chatty, so that has a performance impact as well. And then latency for doing everything. So fundamentally, when it comes down to it, this is kind of a cop-out in a way, but it depends on what the system is being used for. The performance characteristics of one system may not match that of another, just based on usage patterns. But we can look at basic aspects and break those down to provide a better insight into things overall. So calls per second, if you're using Asterisk, you generally have calls coming into the system, unless you're a dialer, in which case you probably have calls going out, which we'll get to here soon. So from a high level how things work perspective, incoming calls come into a channel driver to be processed. This could be Chandati, X2, or PJSIP. In some cases, authentication is done. We then apply some sort of configuration so that we know how to, for example, route the call into the dial plan, what codecs to use. Once that is all done, we then look at sending the call into the dial plan for actual execution, so we can go through the dial plan and handle the call. So from a SIP perspective, which is primarily what I'm going to talk about here, because PJSIP is pretty much our #1 channel driver at this point. PJSIP itself, from performance perspective, is actually pretty fast. So the PJSIP stack, which is a third-party library known, or rather as part of PJ Project, which you can go to pjsip.org and see, has been around a long time. It's been optimized. It was actually originally, or rather not originally designed for, but a focus was put on making it applicable for embedded devices as well, which have specific requirements when it comes to CPU and memory. Though embedded devices of these days aren't exactly like embedded devices of old days. The CPU and memory is quite a bit faster than things used to be. But from a library and protocol implementation perspective, PJSIP is plenty fast. Its parser can handle a ton of messages per second, including enforcing the specification itself. So if invalid packets are received, then it doesn't go too far into the stack. So from a PJSIP library perspective, it's not something that we look at from a performance perspective, and it's not something I recommend people look at if they are wanting to improve performance. Now, there is the second part of the PJSIP, which is our actual implementation of it. And that's also pretty fast. We try to keep things as minimal as we can and as fast as we can. There are some areas that it's just unavoidable that we have to do, for example, lookups in a container, which has a cost. But overall, PJSIP is fairly fast. And recently, as of the last set of releases, last non-security releases that is, it's actually gotten faster thanks to an API called Taskpool, which I will go into a little bit later. So when it comes to PJSIP, where I've seen performance issues is in connecting it to outside resources, specifically databases. When you are connecting anything, not just a asterisk, to a database, you inherently inherit some of the performance characteristics of the database that you are connecting to and the connection to the database itself. So a good example is if you are using real-time in PJSIP, you are not caching at all. That means we are doing a lot of queries to your database for endpoints coming in, grabbing authentication details if you have those configured. So if there's high latency there, then that can have a knock-on effect for performance, and it can really decrease the number of calls per second that you can actually handle. Something else to remember is that if the database is slow, depending on where we are actually handling or doing a database query, that may result in us not sending a SIP response, which means the remote side will generally retransmit, resulting in more SIP traffic, which is another knock-on effect. Starting the dial plan itself is slightly expensive due to creating a thread, but through recent investigation I determined that it's actually pretty efficient at it. So that's not an area that really we're looking at this point. Call setup like this is kind of like an attack on the system just because of how many resources need to be allocated and set up. So overall it's expensive, but in isolation specific parts, they're not that bad. So calls per second outgoing. Outgoing is simpler than incoming. Outgoing channel is requested from the channel driver. Channel driver allocates resources, applies configuration, does DNS if needed, and establishes a call. And then the outgoing channel is given to what has requested it, and then that handles it further. Again, outside access to resources, database yet again. DNS can also have an impact on things. So if in the case of PJSIP, we do asynchronous DNS lookups, which helps in that regard, but that does also consume a little bit of resources, and if they're slow, it can become a poor experience. APIs as well, if you are, before dialing, doing an HTTP request in the dial plan, for example, that can also impact calls per second because we are now relying on your outside service. If you're using the default configuration when it comes to PJSIP, inbound SIP registrations are stored in a local SQLite 3 database. That does cache data in memory just because of the Linux kernel. If not, it can result in disk access, which can be problematic. If you're using a SAN, I've seen issues where the SAN disk I/O latency is just so high that it blocks Asterisk for an exceedingly long amount of time. Long enough that in some cases I've had SIP registrations just expire by the time that it's actually persisted and handled the inbound SIP re-registration. So always keep an eye on disk I/O. Outgoing calls generally don't require starting a thread, so that impact is not as great as incoming. The only cases where that is not the case is if you're doing an originate from AMI ARI, and it's having to go somewhere. Concurrent calls, this is an easy answer. It depends on what you do. Once a call is actually established, the cost of maintaining that is relatively low from a basic level. It can increase somewhat depending upon your configuration choices, such as codec and encryption, but what fundamentally matters is what you do with that call itself. A conference bridge is going to be infinitely more expensive than a file playback, though a file playback is not without a cost itself, because that generally will have to go out to disk. Now we're going to move on to more exciting stuff. So the dial plan. Most Asterisk deployers use extensions.conf, also known as the Asterisk dial plan. There was an effort long ago to deprecate the dial plan. I don't see that ever happening. Dial plan is here to stay, and it's what most people use. However, numerous years ago, it was heavily optimized. So dial plan execution itself is quite fast, and I've never seen it really present any issue in performance. That being said, there is an area where the dynamic nature of the configuration can result in it being expensive, which is variable substitution. Realistically, though, you'll probably never notice it, but if you can be smart about using it, then that may help you in the long term. Dial plan hints themselves, which are mappings in the dial plan to devices. So that's extension 100 at users maps to pjsip/josh. Hints are used heavily in AppQ. They go out over AMI, and you can also subscribe to them from SIP devices. Those, however, are fairly expensive because they are stateful. It has to know who's actually wanting to know about those hints. It's having to keep all that information in memory. When it gets device state, it's having to actually go through and figure out which of the hints it needs to talk to and notify and update. So hints themselves are expensive. Pattern matching hints is also even kind of more expensive because it requires a bit more handling during the reload process. Asterisk has to store that away and then restore it. And then from an operational perspective, when it comes to hints, hints with their current implementation, the way it works is that the PBX core subscribes for every device state update, even ones that a hint isn't actually interested in. So it gets essentially a flood of device state updates as they happen. And then it has to go through all of the hints and figure out which ones it's relevant to. And then it goes through and gets the current device state for all of the devices on that hint and recalculates. So that's expensive currently. I am, however, currently working on improving it. So hopefully in the future, we'll be able to knock quite a bit of CPU cost off of that and make it more efficient. We'll see where that lands. I'm trying to make it so it's applicable to all branches, but maintaining backwards compatibility is complicated when it comes to that. Fundamentally, though, the applications and dial plan functions are really where the bulk of the work happens when it comes to the dial plan. And their cost is variable depending on their application. So my advice is don't focus on the dial plan itself, so the .conf, the execution through the dial plan. That's unlikely to really help you in the long run when it comes to performance, unless it is truly somehow impacting you, but I doubt it. You really need to focus on your actual usage of applications and dial plan functions instead. So PJSIP, like I said, pretty much our #1 channel driver. I think, except for the diehard ChanSIP people, or people who are using Cisco phones with the patched ChanSIP for that, PJSIP is where everyone's pretty much being these days. I'm going to talk a little bit about implementation details of PJSIP, just so people get a better idea of how it's working internally, which may provide some insight into things in general. So our PJSIP implementation, excuse me for a sec. Yay, water. So our PJSIP implementation uses a dispatch model. Essentially, this means that we have a pool of threads in a way, which I'll get to, and also a pool of task queues, essentially. So the way it works when it comes to incoming SIP traffic is that we programmatically determine which of our work queues or task queue that packet should be handled in, and then pass it off to there. So we have one thread which is handling timers and sockets. It does a minimal of work as it can, and then hands it off to another thread or a task queue to be handled. When it comes to other tasks, which are not like network oriented, or rather incoming network oriented, everything goes into a task queue, or whether it's programmatically determined or just one is randomly chosen, because we don't care where it executes. So everything is generally passed off to another queue/thread to be handled. I'm specifically saying queue and thread because they are not one-to-one. A queue does not have a dedicated thread. There's the number of threads that PJSIP can use for this work. There's a minimum number, and it can grow as needed. So it's not a one-to-one mapping. This work, or this approach, previously used our thread pool implementation. The thread pool is exactly what it says on the tin. It allows you to have a pool of threads. It can grow and shrink. And if you just want to throw something into the pool for a thread to execute, it can go there. I had a hunch a while ago, last year, before I went on vacation, that the cost of thread pool was high. And so I prototyped, experimented to determine that, yes, the cost of doing that is high. And so I came up with a new API which is better fitted to the usage pattern of tasks which execute a short to medium length of time, which I call task pool. If you'd like to know more about task pool, I also have a blog post on asterisk.org talking about when I wrote it and some metrics about it and stuff. So it landed technically a few releases ago for stasis, and then as of the last releases, non-security, it landed for PJSIP. So by moving from thread pool over to task pool, we decreased CPU usage about 8 to 10%, which is great. Stasis was more like 20 to 30%, I think it was. But every little bit helps. So like I said before, PJSIP stack underneath is generally quite fast at operations, and our higher level usage of it, we try to keep simple. Like I said before, where things can fall apart is outside resources usage. Real time, I can't repeat this enough. Real time is not free. It has a cost. And people, I think, have been conditioned due to connecting websites and stuff to databases that they just, from a user perspective, you just have a different expectation when it comes to a website versus a phone call. If a website takes a few extra seconds to load, we can tolerate that. But from a SIP perspective and VoIP perspective, if things take long, then that has protocol ramifications as well as just user experience ramifications. So real time is synchronous. It has to be, because it's going to get data that's needed to process a call, so it can block threads, which then increases the handling delay. It can cause buffers to fill, network buffers. It can cause packet retransmissions. It's generally not great. So if you're going to use real time, don't try to be clever and connect your asterisk to a remote database. That latency, if it's large enough, is just going to cause you headaches. Another thing is that make sure that the network connection between asterisk and the database is clean. And by clean, I mean ensure that there is nothing configured to actually do packet inspection and manipulation or blocking, because that can have ramifications on the underlying database protocol, which can really confuse the libraries for these databases. A good example is MySQL. If something happens to the connection there, it can get into a really wonky state. We do have source-free caching, which is available to try to minimize and reduce this by caching data in memory. See the docs site, docs.asterisk.org. It's very configurable. It can work great. However, there are cases, such as when you're persisting or writing out data, where that is not cached in memory and does have to persist out to the database. So it's not a magic fix-all band-aid. Configuration, like I said, can have an effect on CPU usage. And as well, PJSIP being a newer module can also react to task processor overloads. This is configurable in pjsip.conf if you need to. And it aims, when task processes are overloaded, it assumes that the system is overloaded, and so it tries to reduce the strain on the system by ignoring new calls. So you can configure that if you want to disable it, for example. Now, programming interfaces. So AGI, that's split into two options: executing an application, AGI, and establishing a TCP/IP connection, fast AGI. For large-scale systems, using fast AGI is vastly superior because executing an application using AGI can be expensive. And this depends on the memory usage of Asterisk itself. When Asterisk has to launch that application, it has to fork itself. If Asterisk has used a lot of memory, that operation can take a longer period of time, and it can cause certain aspects of Asterisk to pause. Asterisk itself doesn't exactly pause, but timers used by Asterisk do. So this manifests as audio blips or pauses during playback or in conference bridges. If you use fast AGI, you don't experience that. However, once actually started, AGI is fairly lightweight. It's got a minimal of bespoke things inside of it that are specially coded for within AGI. It's mostly using common interfaces, dial plan applications, and dial plan functions. So the cost really comes from that initial launching of the application-based AGI. So if you've ever experienced that, switch to fast AGI. AMI. So AMI, the Asterisk Manager interface, it can produce a ton of messages because it's a bus of events that are happening within Asterisk. If an AMI application wants to actually receive them, it's going to be sent. If there's a ton of them, they may end up buffered. So the thing here is if you can reduce the number of messages your application needs, the better, specifically by doing the filtering on the Asterisk side. If it still needs a large number of events, then use multiple AMI applications or multiple connections, each receiving different events. There is a consequence of that, though, in that the events will not be serialized. So depending upon how you're using them, you do have to take that into account. And something else is that the speed at which the AMI application reads or receives the events will have an impact on the Asterisk side. Network buffering can only do so much. So one potential aspect is also to read and buffer in your application as well. So have a queue of work in the application itself too. ARI, Asterisk REST interface. ARI, I just want to start by saying ARI is not a replacement for AMI. ARI receives a subset of the events that AMI does. So ARI fundamentally has less events and receives less events. That being said, it can still produce a decent number depending upon usage. So the recommendation, just like AMI there, is to do server-side filtering to reduce the message load to your ARI application. So if you're not interested in certain events, tell us and we won't send them. That reduces the network traffic and also reduces the amount of processing you have to do and also helps on the Asterisk side some. I would also like to throw out that ARI now provides outbound support, so you can load balance your application. You don't need to have one application receiving everything or try to do load balancing using multiple applications in the dial plan. So you can just send it to an HTTP load balancer that's WebSocket aware and do it that way. Something else we added is the ability to do HTTP requests over the WebSocket. So you don't need to figure out how to get HTTP requests back the normal port 80 other connection way. You can just send them over the WebSocket instead, which also simplifies things. So depending on the scale of your application, that can be a great approach for allowing it to scale better. Now, some commonly used functionality. CEL and CDR. So CEL, or call event or channel event logging, is chatty. it's giving you not as many events as AMI, but it's still giving you a fair number of events that are related to the channel as it progresses. And this is so you can interpret those events and create your own CDRs. CDRs are fundamentally business logic. I've never seen anyone truly agree on how CDRs should be because, like I said, business logic, so everyone has their own idea or needs. We do provide CDRs, so CDRs produce much less records as a result. Generally, it's a record per call leg. So if you're doing transfers, more call legs, but in comparison to CEL, it's considerably less. Now, going back to what I said about dial plan and variable substitution, these modules, when it comes to certain output or back-end modules, do use variable substitution. CEL custom, CDR custom, they allow you to configure essentially the lines that you're going to output using dial plan variables that get substituted in. It has a cost, but we are working to add alternative configuration which will substantially decrease the cost of doing so. This is being done by George Joseph, and in fact, he's also come up with a way to allow it to automatically work for a good portion of configurations. So that should decrease the cost there, which will be nice. Going back to database, I'm a broken record on this. I freely admit that. Directly connecting to a database, it can be convenient, but throughput of the database, particularly for CEL, can be a problem. So my recommendation is to do post-processing instead of the records that Asterisk is outputting, and then shove them into the database. The nice thing about that is you can store them in a like locally on disk, for example, instead, so that if something does happen to the database, then they can still accumulate, and then afterwards the database comes back, which hopefully it should, you can go ahead and bring those in. Transcoding. This is easy. It's CPU, CPU, CPU. Transcoding is pretty much CPU-bound operation. If you reduce your transcoding, all the better. Store SAM files in the codecs that you use, for example. So if you're doing ULA G722, store 2 copies if you can. Disk should be relatively available, so you can do that. As well, not all codecs have the same cost for transcoding. You can check out Core Show Translation for how long stuff takes. Transcoding G722 between ULA and ALA is a lot simpler than something like Opus. Opus has gotten cheaper as things have gone on and it's been optimized, but Opus itself is also a very expensive codec. For example, a few years ago, I don't know how many it would be, as phone manufacturers were starting to implement Opus, the underlying CPUs and chipsets that they were actually able to get just wouldn't support 2 legs of Opus at a time. You can only do 1. And that's just because of the complexity of Opus. Things have improved there, but Opus is still expensive. Bridging. So 2-party bridges are simple, but going back to transcoding, if you're transcoding, then that's where the cost will be when it comes to a 2-party bridge. Multi-party bridges are just always expensive because media has to be transcoded to and from signed linear. It's always going to happen. So codec choices become even more important there. So when it comes to bridging, bridging itself, not bad. It's just transcoding that's the issue. So implementation comment. I talked a bit before about thread pool when it came to PJSIP. So I'll talk a little bit more about this, a little bit more detail. Particularly the third point down. If you saw task processor warnings on the Asterisk console about stasis/pool, that was the thread pool. So the way the thread pool works is that you give it work, that work goes into a single queue, Another task is queued to then wake up or create a thread if possible, a thread, and then some work is given to that thread. That single pool where all of the tasks would live could grow quite a lot depending upon how fast or how many threads were actually available. So if you had warnings about stasis/pool, that should now be resolved as of the latest releases. Well, technically the last 2 or 3 releases, I think it should be resolved. So that should no longer happen. So just putting that out there. So the number one thing to remember, everything has a cost. It's obvious. It's a kind of a throwaway kind of sentence, but it's true. The less you do, generally the more you can get out of the system. My recommendations, reduce reliance or dependency on outside systems if you can. Reduce transcoding, so minimize it as much as you can. Reduce how much work any of your external applications, so that's ARI or AMI, have to do. Keep things as simple as you can. Don't try to be clever. Don't try to go fancy. Keep it simple if you can. If you have to do something, then reduce it or optimize it if possible. Now, some things to monitor. SIP response time to incoming requests. So you can send in SIP options. SIP options will still flow through the dispatch model, which means you can see how fast stuff is being dispatched to handle. If that's creeping up more and more, then that may indicate that if you're doing a database, that something's up with your database. It could indicate that you are seeing an increase in SIP traffic and it's taking longer to handle it. Or that something internally in Asterisk is finally reaching a point where it's impacting your performance in some way. SIP qualify time to endpoints. So if the time to qualify stuff is creeping up for essentially everyone, then that can indicate that you might be having network issues. There might be retransmissions going on. The dispatch model, yet again, could be having issues and is getting overloaded or blocked on something. You want to monitor the number of registered endpoints. That's whether it's performance or just in general. That is a great thing to monitor, because if your registered endpoints are trending downwards or suddenly goes down by a large number, then that can indicate that something in Asterisk is blocked. One sec. I could pause this recording, but I'm not going to. So for example, when it comes to the dispatch model, you can technically have one of the task queues blocked indefinitely. And because we use a programmatic approach to distribute tasks out, that won't manifest as all of Asterisk or all of PJSIP blocking. Only a subset of it would. That can increase if what it's blocking on is something used by the other task queues, but it may not be. So monitoring registered endpoints is a great approach for that as well. AMI response time, if that's creeping up, then you may have an increase in events being generated. Your handling could be not as fast as it normally is. You might be CPU starved on the application. Task processors, so core show task processors, in particular overloads and maximum queued. Task processors themselves are much to probably what people have said. Task processors themselves are incredibly efficient. It's all the users of task processors that can cause issues. So core show task processors can show you specific subsystems that may be starved for CPU or may be having issues. So if that's creeping up, then that's something you want to keep an eye Standard stuff, CPU usage, memory usage, disk access time, and IOPS. If disk access is not what it should be, then that's going to have a knock-on effect for other things, particularly inbound SIP registrations. Those will start lagging, you get retransmissions, which will cascade, and it's just not great. And then, like before, outside services like your database, monitor your database if you're using it, as well as DNS latency. So some configuration and implementation suggestions. Endpoint configuration, restrict codecs. A lot of people just throw allow equals all. Don't do that. Restrict it down. Know what's in use. Be specific about it. Real time. Yet again, I'm a broken record. Avoid using an external database if you can. It doubles your scope of potential problems and can cause issues. If you must, when it comes to PJSIP, you can use sorcery caching, which will cache a ton of things in memory depending upon your configuration on the read side. It will not cache writes. Writes will still go to your backend. So if writing is slow or database having issues, then that can manifest itself. AMI and ARI, filter it if you can, or reduce your traffic in general. Task pool, that new API I mentioned, monitor core show task processors for the task pool ones and adjust the respective configuration. I think realistically, it's unlikely you'll need to. Dial plan, don't go overboard with variable substitution if you can avoid it. And then ultimately, test. Set up a test environment for your usage to understand how things react to it and get a better baseline for what is normal for you. Deployments and systems are not created equal. That even goes down to the CPU. So you need to test and figure it. Overall, though, we will continue to improve performance. It's a personal side project of mine. I want to improve performance for everything I can. And with that, thank you. And we're now going to try to do a Q&A live over video conferencing. We'll see how that goes. If it does not succeed, you can find me on community.asterisk.org, the forum. Feel free to ask questions there. I'll respond to them. I always generally do. So I look forward to seeing everyone there too. Am I up? Have a great day.
Check 1, 2. Oh, hey, get out of the way there. Thanks, Josh. That was a great performance improvement overview. The stats look pretty good in a number of areas. We are looking for some questions now at the end of your talk. If anyone has a question for remote Josh. Josh, are you there?
I think I'm here. Can anyone really be sure? I could be AI, to be honest. Who knows?
There we are. Yes, we hear you at least.
I will say, if anyone thinks of questions later, as I said in the video, just post them on community.asterisk.org. I'm always
Okay, I guess that there's a request. Yeah, Josh, you speak a little louder maybe into your mic. We heard that. Yeah, let's post them to the community forums. Rajan, back here.
So Josh, you mentioned a list of things worth monitoring. I was curious if you had settled on some sort of an observability stack. What would you recommend to use to monitor those things?
So
can't say I've settled. I have no control over volume, so that's on your side. From an observability stack perspective, haven't settled on anything specifically. Many people have different opinions on it. From a data perspective of what past people of Asterisk developers, I wouldn't say settled on, but implemented is some StatsD stuff that can be pulled out of Asterisk. There's some Prometheus stuff as well, but really we haven't defined anything of the complete stack of what to use. So honestly, it's up to you. Whatever works.
I'll throw in a quick plug, maybe Homer. I think there's a HEP module that they've worked on. It's a larger observability across a number of different open source web projects, so that it's worth a look. I know they strive for some Asterisk integration. It's a third-party project, so I guess can't really speak to it too deeply, but I think there's a few. Any other questions here for Josh, remote Josh? Oh, hey, Al.
Hi. About AMI filtering, what is the cost on the server to put some filter, especially regex filter? Does it, what are the benefits on the server compared to what we gain limiting the outputs and having some extra CPU use because of the filtering?
So the traditional AMI filtering ends up being quite expensive, the regex-based stuff. The newer generation stuff, which is more intelligent and explicit, is a lot less CPU. I think George did a blog post about it where he talked about it. So the newer stuff is the way to go. The cost of doing it on the server is fairly minimal. But it ultimately depends as well on how many messages you're generating too, the actual usage pattern of Asterisk according to your use case. So it depends, but the newer generation stuff is considerably better, and the penalty hit of doing it, server side using that is not that high in comparison to sending all of that down to an application and the application having to deal with it. Since in our experience, trying to do it on the application side, it's painful and it doesn't scale and it doesn't work well.
I think a minor shout out for George too in regards to some of the tools. I think for the performance monitoring, he's the process of releasing. Is that right? Do we have some more repos? I think maybe I'm speaking out of turn here. So.
Yeah, sort of incidentally to some of the other testing he did, he came up with some performance stuff you can run.
Can't hear you.
Oh, that was another guy. George has released a couple of tool sets that he created as part of testing everything else. So.
I know. Spoke on some of the other performance improvements earlier in the year. In regards to some capacity improvements and things, and so so we've had a few internal tools. Hopefully we can release more of those soon. Follow up on that question. All right, well, we're a few minutes after 5. There's no further questions. Just say thanks, Josh, again. So not sure if you heard your applause earlier, but we can clap again, I guess, so you can. And another shout out. There's a few more Asterisk engineers and some other Sangoma folks here too. So if you take a look at everyone's badge, you can wave if you like. Looking around for where they might be. I like it. We've got a lot of great resources available here at this meeting. So thanks again for coming. For the first day of AstriCon 2026, we'll get started again tomorrow morning, Friday at 9 a.m. with some AI talks, a couple of those, and of course, and then we'll have some other discussions about more Asterisk improvements, or kind of an overview of the project and where it's been, as well as a FreePBX talk. So I know there'll be a shout out for some community contributed improvements there, and I think that this is going to wrap up around 2 o'clock tomorrow. So if you didn't grab your t-shirt yet, please do that on your way out. So if you want to wear that tomorrow for the group photo at the end of the day, that'd be great. Or I guess you could just change at lunchtime if you don't think of it. Again, all the speakers, if you haven't grabbed a mug yet, please do so on your way out today as part of your extra swag for coming to speak. Thanks again for doing that. Thanks all to attending, and we'll see you tomorrow for day 2 of AstriCon 2026. Thanks all.